Surprisingly enough, I cannot hear shit, and... Is that because... Can you hear me, by the way? Oh, okay. There we go, so there's something wrong with them. The music is still sort of lagging. I'm not sure if you can hear it, but it's just lagging a little bit. At least for me. Maybe it just needs... I don't know what the fuck is going on with the music. Can you hear that the music lagging, or is it only me? Could you hear at least, because I actually stopped it? Okay, whatever. So here's an interesting thing. I forgot the name of the project that I had to go to. It's called Automata. So let's take a look at what killed my entire fucking machine. I don't see the square. This killed my entire machine. I have no idea how this killed my entire machine. Okay, sure, it's an infinite loop. This is probably... Yeah, I think I kinda know how that could kill my machine. If SDL... is the music too annoying? Please tell me. I need a feedback because I don't know what's going on. Is the music too annoying? Can I just leave it in? It is lagging like crazy. Everything is goddamn broken on my machine. Alright, so... I'm gonna turn off the music then. Like, holy shit. Oh, fuck. If it uses some sort of like a batch renderer, right? If it uses some sort of a batch renderer, it probably maintains the list of the things that it needs to render on the next frame, right? So it probably doesn't render things right away. It renders them later, right? And if you start... So to do that, it probably maintains a list of the things, right? So basically you draw a line, but what it in fact does, it just, you know, schedules to draw a line and put it into list of lines to render. And then probably it creates a shader with all of the lines available and draws that in a shader. So at least this is how I would do that, right? This is how I would do that. And if you start like pushing these lines in a loop, right, so that means that could consume all of the memory, starts consuming all of the memory if this thing doesn't have any sort of limit, right? And that could potentially kill the entire machine. You see what I mean? So that could be an explanation. So by itself, this thing doesn't really do anything. By itself, it doesn't really do anything, but if the SDL works the way I think it works, and I think it actually does work this way, it may basically consume everything. It just depends on how it schedules everything. Waka Flame, thank you so much for the gifted sub. Thank you. All right, so let's actually take a look at the source code of SDL, because this is actually very interesting. Just to give me time to find motivation to keep doing that, because it's kind of goddamn hard to keep yourself motivated when nothing is fucking working and chat is actually tries to, you know, fucking annoy the fuck out of you, right? So okay, let me see. So let's find the implementation of this function, right? And here it is. So it uses this function like render draw lines f, And let's actually try to go there, right? So it's going to be something like grep rn, where it is. So this is just an external declaration. Right, it's just an external declaration. And where is the actual implementation? I feel like the actual implementation could depend on the driver. It could depend on the driver, but looks like here it is. So render lines QCMD draw lines. This could be the case. As you can see, it queues drawing lines. Well, so it's already, you know, kind of works the way I described, right? And even though, like, I never read, like, properly SDL, I don't really know how it renders things. But I could imagine that this is how it does that. At least this is how I would implement that personally. Right, so prepare a QCMD draw solid. So it prepares some sort of a queue, then queue draw lines. And okay, this is interesting. So it uses like an internal method of renderer, right? It uses the internal method of renderer, and that thing is very much driver dependent, right? So in OpenGL it probably does one thing, in Direct 3D it does another one, and so on and so forth, right? So let's actually take a look at what we have here. So let's try to specifically search for this one. And yeah, as you can see, we're starting to see different drivers. We just see different drivers in here. And let's take a look at the OpenGL one, because that's the one that we use all the time. And what does it do here? So queue draw lines. Yeah, so it's the GL version. SDL allocate rendering vertices. So we're allocating some stuff. And then, yeah, I think the most important thing is probably here. So it keeps allocating the memory. So let's try to find this function then. So I think this is the, unless I miss something, I think I didn't miss anything, because we're just allocating it, and it probably allocates it in some sort of a allocator or whatnot. And yeah, so okay, let's take a look at that one. So it's going to be like this. Alright, and where it is implemented. So I suppose, yeah, sounds like it's something very much driver dependent, but not really. So it's using this function everywhere. And this could be the implementation. Well, there we go. There we go. So interesting. Every time you draw something, you potentially reallocate memory using SDL. So this code, as executed, this entire function is executed every time you call draw line, and it potentially reallocates memory with its own allocator. Let that sink in. Right. Every time you draw a line, it potentially may start reallocating the memory, right? And if you start drawing lines in a loop, the memory is growing, it keeps reallocating it, and God knows how many times it will start reallocating if it goes into an infinite loop. And at some point it may execute that thing, but since we're like on x86 64 with virtual memory and swap, it like virtually has no limits for the memory, so maybe this thing will never be called, and that will just basically consume everything from my system. I think it explains everything. SDL is just a piece of shit. That's the explanation. Interesting. If you're not careful, it just fucking kills your entire system. Thank you, SDL. Very cool. You could have implemented that a little bit better, I suppose. Maybe some sort of like a limit. I don't know, because there's a limit to how much you can render anyway. It's kind of shitty library if you think about it. Like if it's organized like that, it's kind of meh. Right, could have been actually implemented way better. I like it. But yeah, that's essentially what killed my stream, and the VOD is split and everything. But it was educational, I suppose. It was kind of educational. which can be order. But I mean, whatever I said, I didn't propose as a final solution. What I said is that you could have done it better. And like, doesn't matter what exactly I said. What I said is that you could have done it better. Specific may vary. It just needs to, like, you know, a little bit in actual research. Can you fork? I don't have time to maintain the forks of SDL. I have too many of my own projects to maintain someone else's projects. No. The only thing I can do is complain about state of the world. All right. So let's continue. Let me see if the music became better. I don't know if it became better. Something wrong with Pulse audio after the restart. Maybe the caches has been warmed up a little bit. Let me see. So it does not lag anymore, at least. It still lags, and I don't know why. Like, from time to time. And it's really difficult for me to know why. So what's funny is that this specific lagging is attributed to, I think, Chromium itself, because I only experienced it in Chromium and nowhere else, which is kind of interesting. So VLC works usually fine. MPlayer, MVC, I think it's called MVC, but yeah. It's usually like this kind of lagging sometimes happens to me out like off screen, and it's only in Chromium. It's only in Chromium. But I never tried Firefox, so never tried Firefox. Also, I think my system is dying yet again. And everything is super slow right now, even though I restarted the machine. But yeah. What is this shit? Oh, it's one of the things that they opened for Wire World. What a shit show stream, am I right? What a shit show stream. So maybe I'm gonna make a cup of tea. Does anyone have any questions? While I'm making a cup of tea. MCQ8, thank you so much for 6 months of tier 1 subscription. Thank you. And welcome to our Epic SDL Club. Don't worry, now I know not to use SDL. I guess, but it's not like you have too much choice unless you want to implement everything from scratch. Which is also a valid option. For example, this is something that John Blow would do, right? So if he needed his own SDL, he just implemented his own SDL. So yeah. Hello Ash and the Riot. Thank you for the raid, Freeman 4069 420. Thank you. But SDL not that bad, and you don't want to do it yourself. How do you know if I do want to do it myself or don't want to do it myself? Maybe I do want to do it myself. Like, who are you to tell me what to do? I don't know, John Blow just implemented his own SDL. Works fine. Works on all the platforms. Works on Windows, works on Mac OS, and works on Linux. And it's even more powerful than that. It also handles 3D. So, I don't know. Maybe you don't want to do it yourself. But that sounds like your problem. Okay. I'm gonna go to the kitchen super quick and turn on the kettle. And yeah, I'm gonna be back. Just because I do nothing all the time, it doesn't mean you can accuse me of doing nothing. So let me see. Let's continue. So here's the why. I forgot what I was actually implementing. I forgot what was actually implemented, and I need to be super careful. And somebody in the chat said that the time has come for W error, and I think you are right because yeah. So if I actually do W error, will that save me from this kind of shit? I wonder. But yeah. So first of all, also let me actually do something like this just in case, because I'm not sure if W error will save me from this kind of shit. Yes. And I really like how my system like instantly froze. It almost instantly fucking froze. Yeah, just holy shit. One mistake and you've mistaken. Okay, statement with no effect. Okay, so actually that helped. That actually helped. What if I remove exit? So maybe the exit? Yeah. So essentially what I have to do here is just to do plus plus. That's very interesting, and that was extremely educational. Yeah, even though we lost a lot of viewers because of that. But at least I learned something. I'm actually thinking, maybe the time has come to fucking implement my own SDL. You know? Yeah. Because I am always like sad how SDL actually limiting me in what I can do, right? I could use OpenGL, right? But I want to abstract away from OpenGL as well. Maybe that's also kind of cool. I don't know. But yeah, in SDL, how many backends SDL has? It has OpenGL backend, it has Direct 3D, Metal, Vulkan, Frame Buffer. I think that's the all things I have from the top of my head. Maybe web, it probably also has web. Maybe in the source code itself there is like a list of the available drivers and whatnot. But yeah, maybe the time has come to implement our own thing. Who fucking needs any goddamn music? Am I right? So now this thing seems to be working. It seems to be working. So it's going to be world, and here's the grid that I was talking about. But at some point it will become like a really unreadable, and I'm thinking what would be the best threshold for actually hiding it. The best threshold for actually hiding. Okay, so this is going to be grid color, right? This is going to be a grid color, and that didn't really do anything. So let's put it this way. And here it is. So yeah, it's really subtle. I wonder if it affects the encoding right now. Does it really affect anything? I'm not quite sure, but yeah. Okay, so and yeah, there we go. But what's interesting is that it can move in all the directions, which doesn't really make much sense because it shouldn't. It can move in that direction, it can move in that direction. So there's something fishy going on, unless we try to do something like this, right? Maybe I implemented it incorrectly. Because according to the description, according to the original description, it it actually stops when, like in here, but not really. But I would expect it to be stopped. Huh. So it was something like this, right? It was something like this. 3 neighbors should not change. Yeah, it seems wrong. No, it's actually working. It's actually working correctly. As you can see, it stops. It actually expects a very specific orientation, right? It expects a very specific orientation, which is interesting. All right, and so if I try to run something like BB, all right, we can clearly see that. But if I now make square, it's like a diode. Yes, it goddamn is. It is a diode. How did you guess? So for those who just joined recently, so we're trying to look into this cellular automata, which is actually suited for simulating transistors and like generally like electronics and whatnot. So yeah, and you can even like build Turing complete computers in it or whatnot. So, and I really want to be able to 7-segment display. It would be kind of cool. Like, where can I get more information on this thing? Because it's amazing. There's not that many resources on this like thing. Scientificamerican.com. Why do you need several cores and not only two? By the definition of the cellular automaton we're implementing. We're implementing a cellular automaton called wire world, and it has 4 states of the cell by the definition of the cellular automaton. Does it make sense? So you can find the definition here, and it describes it like as clear as it can. So yeah. So what do we have now? Okay, wire world computers. So maybe we should try to. This paper describes how we went about building a wire world computer, although at least one design exists for a tape-based Turing machine implementation in the game world. So maybe we can download some actual files. Is there something that I can download? Introduction. So here's introduction. So I had copper. Oh, they called conductor copper. So there's a head and tail, and the diode. The diode looks like this. Okay, so the diode. There's also OR gate. Oh, that's cool. There's an OR gate. Exclusive OR and not ROM. Oh shit! Can we make an adder? Holy fuck! We need to make an adder since we have all of these shits. Yeah. So that's you can also. Oh, there we go. They even have a binary adder. Okay. Holy shit! That's so cool. Yeah, here it is. Is there any way to download any of these things in any particular format? Experimental demonstration of the world. Okay. Holy fuck. Because I know you could download like a leaf files specifically for seed. Right. Can you download any files? You can see in running computing design here. It's programming. Oh shit, is it actually implemented in Java? It could be actually implemented in Java. Okay. Experimental demonstration. Static wallpaper, which can scale as you wish. Oh, that's not bad. Maybe we can parse this thing from here. That's kind of cool. So yeah, pixel by pixel, we could probably actually parse it pixel by pixel. Sounds like a very interesting idea. I'm not gonna lie. Just parse it pixel by pixel, and then load it into our simulation. And yeah, that's super fucking cool. I want to do that shit. So, but first, let me take a selfie. I'm sorry. Too much tea. Too much fucking tea. It's actually kind of awkward without any music. Maybe while I'm doing nothing and not saying anything, I should play music. Why no music today? Because it's lagging and my computer is dying. So it actually makes the music unbearable. Wish we could listen to music, but we cannot. But it's even better, you know, DMCA and stuff like that. DMCA, I'm sorry. It's fucking GIF. Who the fuck puts static images? Okay, so maybe it's a very old image, and at the time maybe like using GIF provided some sort of like a good compression and whatnot. Yeah. Alrighty, so let me see how we can do all that. So we have a grid, and let me do a committee, and maybe even a pusher. Oh yeah, I wanted to take a look at how grid looks like when you have 100 by 100. I think it looks like shit. It must look like shit. That's one of the reasons why I didn't want to introduce that. Square.h, where's 20? Jokes on you, I have my own music. I'm gonna ban you. I'm gonna straight up fucking ban you. How dare you? How dare you to have your own music? You're banned, straight up. Alright, so what do we get? Are we gonna parse the GIF pixel by pixel? Yes. It's actually easier than you think. Because apparently I think it was generated in a very dumb way, where literally a single pixel is a cell. Yeah, you can even clearly see that. Look. A single pixel, well, there is a little bit of bilinear interpolation, right, because I zoomed in, but if we actually disable bilinear interpolation, I think it's a 1 pixel equals cell, which makes it super easy to parse and whatnot. And I especially like these comments. They actually made comments with the conductor itself. This is so cool, and it should work according to the definition of the cellular automaton. It should actually work. Holy fuck! I like. Oh, this is so fun. All right, so yeah. By the way, for those who doesn't know, like who want to take a look, here it is. Also, because it's a GIF, the colors are probably into static palette. Yeah. So. I think we're gonna use SBT image. I'm pretty sure SBT image can parse GIFs. It cannot parse animation of the GIFs, but it can at least parse the like a static image. It's like Minecraft sockets. Yeah, maybe. They work slightly fundamentally different, but I mean, yeah, I guess. I would argue that making computer in a wire world should be a little bit easier than in Minecraft Redstone. Yeah, because this looks less complex than some of the Minecraft computers I've seen. And ironically, this looks less complex than some of the Minecraft shit. It's not that complex compared to what people do in Minecraft, come on. So let me see. I'm gonna run the while world, right? And so how is the encoding, by the way? Tell me that encoding is shit. Is it shit? Is it unironically shit? I'm pretty sure it is. Not yet. It is very shit. Okay. Cool. Thank you very much. So, and this is the reason why I wanted to actually disable this entire thing. Or maybe we can toggle it. You know, let's do it like this. So it's gonna be like this: bool grid, right? So this is gonna be boolean grid, and essentially, if context grid, we're gonna move this entire shit in here. Here's the context grid. Only then we're gonna render the grid. And every time we're handling all of the events, so this is where we handle all of the events. And then if context core keyboard G, right? If the user pressed G, we're gonna do context grid, not GRUD, but grid. So it's gonna be something like this. Hello, Nutrix Life, welcome to the stream. Now. Okay, that should be alright actually. So let me try to do a make minus b. So, well, I mean, there are more like reliable strats. Basically, try to violate TOS. If you try to violate TOS, I think you're gonna get banned, guaranteed. But I heard some would say that it's a little bit of a cheating, right? Using the Monka TOS strat is a little bit of a cheating. So I think getting bad speedrun should be without trying to violate the TOS. This is like a more hardcore way of speedrunning the ban. Yeah. But again, if it doesn't work, you can always just violate TOS and you just instantly get banned. So anyway. Not like I know anything about banned speedrunning strats, I'm just saying. Alright, so while world, and now I can enable and disable grid as I want, which is actually super convenient. So now if I go to the square and I'm gonna just make it something like 20 by 20, and I forgot to rebuild everything. Oh my god, make minus b, there we go. Violating normal law. What is a normal law? Oh, you mean real life laws? That's what you mean. Okay, I see. It's kind of interesting how it... Huh, look, this is so cool. It actually splits horizontally. If it goes vertically, it will split horizontally. But if it goes horizontally, it will split vertically. This is so cool. I like it. Wait a second. This is so nice. Yeah, this is so cool. I think it will short circuit the first instance I try to do something like this. So let me first do it like that and then do it like this. Oh shit, yeah, you can actually cycle that. That's so cool. You can actually cycle that. Well, it acts almost, if you think about it, it acts almost like an electron. Because electron is not particularly a particle, it's also a wave, so it can go in two wires simultaneously, right? It can go in two wires simultaneously. So yeah, it kind of does simulate it, but I'm not a physicist, so I don't really know much about it. But yeah, that's cool anyway. You can also disable the grid. Then we're back. Not like Electron. Yeah. Okay, so let's try to also cycle this. I think I need to update my framework to be able to pick a specific cell. And it starts to isolate. Yeah, it starts to isolate. It's happened because you look neighbors that way, right? You can prioritize neighbor lookup on the rows first. Why do I need to alter the definition of the machine, of the automaton? Like, here's the definition. I implemented the definition and it works the way it's supposed to work. Why do I have to change anything? I don't understand. What's the point? All right. Anyways. So we introduced the grid, so we also updated some of this stuff. Okay, so I need to commit whatever we have already. So enable WR just in case I didn't enable this once and it killed my laptop Monka Mega. There we go. So from now on, I'm gonna be fucking enabling this shit. Holy shit! I thought that WR actually sort of prevents me to quickly iterate on the development, right? But after this situation, no, I don't know. I have a PTSD because of that. All right, so also I'm gonna introduce the background. So here's the square, here's the seats, game of life, core, nothing particularly special. Make the backgrounds of automata transparent. There we go. So they are transparent now. Then yeah, forgot to commit the yellow color, right? Forgot to commit the yellow color. And the next thing we need to do, we need to introduce the grid functionality, right? So by the way, I think I need to add the controls in here, right? Controls, because core has its own controls as well. So in a core mode, you press space and you can pause, and that is implemented for you. Here we can do the following thing, something like G, toggle grid mode. Yeah, let's just call it toggle grid. Commit message forgot to commit. Did I call it forgot to commit? Wait a second. No, I didn't. Okay. So what do we have here? So this is a draw line. So is this something that I forgot to do? No, apparently I forgot to actually realign everything. Okay. Implement grid mode for square framework. So now we have just god damn it. And we also have like a slightly slowed down generation. You know what I also want to be able to do? I want you to be able to change the timeout of the generations at runtime as well, if you know what I mean. Because recompiling everything every time you want to just slow down things is kind of not particularly convenient in my opinion. I think it would be better if we, you know, if we were able to do that at runtime. I think that will be actually pretty pogue. And anyway, I'm gonna push that right to the repo. You can find the source code of everything we're doing here, of course, if you're interested in this kind of stuff. Alrighty, so what's gonna be the next thing? I'm just thinking, do I want to work a little bit more on the runtime stuff? I think I want to work a little bit more on runtime stuff, and then we're going to try to parse the image, of course. So for how long am I streaming, by the way? So I'm going to stream up until... yeah, so the restarting the stream actually screwed up with my timer, and I don't know for how long I'm streaming already. So it's going to be a little bit painful for me, but yeah. We'll see. So in the core, what do we have in the core? So we have the actual timeout, right? We have the actual timeout, and I needed two variables here, actually. I needed two variables. So this is the timeout, but the variable, yeah, it should be called cooldown. This should be called cooldown, and then we're gonna have next gen timeout, which basically resets everything. The first bit was 57. Okay, so around an hour. So I'm gonna just add an hour to how much I'm streaming, and then okay, that's actually pretty convenient. Thank you very much. I'm gonna replace that with cooldown. Right, it's gonna be cooldown, not that one, but there we go. And it seems to be working. It seems to be twerking. Cool. Yeah, then we can enable that, and that's pretty cool. So now in the core, on top of that, we're gonna have next gen timeout, right? And when I do core begin, I also initialize the timeout with context next gen timeout with next gen initial timeout, right? Initial timeout, oh, it's just gen timeout, initial 005. Cool. And now what do we have here? This one is going to be context next gen timeout. There we go. Cool. Nice. So after that, we can try to add the handlers for things to speed up stuff. How we're gonna speed up things? Case SDLK. So G is already grid. R resets everything as far as I know. So maybe X is gonna be speeding up, right? But the question is how much we speed up, and also speeding up should be by multiplying, maybe. No. Okay, X should reduce the timeout, so it's going to be context. Context. I cannot type. Context. Next gen timeout. And we actually just multiply it by 5. So essentially, the smaller it is, the slower it will be decreasing. The bigger it is, the bigger it should be increasing, if I understand correctly, right? Hopefully. Yeah, but it shouldn't be like bigger than a certain value, and it also shouldn't be smaller than a certain value. So we're gonna have something like f max f between that and next gen minimum timeout, minimum timeout, something like this, right? Minimum timeout, there we go. And that is kind of scuffed. I don't like that, but we can do it like this. So, and then SDL key, X actually does what? It reduces, that means it speeds it up. So Z should actually increase it, hence actually slow it down. Right, so there we go. There we go, and this is going to be 2, and it shouldn't be bigger than max timeout. And we have to define all of these constants in here. Right, next gen, there we go. So minimum is going to be probably maybe, I don't know for how big we want to make it. So this is going to be minimum. Maximum, I think more than 1 second doesn't really make much sense, but maybe you can make it as big as you want. Right, so the only thing we don't want this thing to become is negative or 0. So this is going to be the minimum timeout. So maybe for the max timeout, we're not going to even, you know, limit it. You can make it as slow as you want. Doesn't make much difference. All right. All right, so maybe I'm gonna also run BB, and so I can now slow it down. Right, it should be super slow. And what's interesting is that every time we change the next gen timeout, I think we should reset next gen cooldown to that timeout. Otherwise, if you make it super slow, you will never be able to wait until the end of the next cooldown. Right, so I think that's quite important, if you know what I mean. So we can slow down, we can make it super slow, and then we can keep increasing this thing, and it doesn't goddamn work. I wonder why. Probably when you keep increasing it, like, it should actually divide it by 2, but I really want to know the actual value here. So let me actually print this value. So it's going to be something like f, and I'm going to get the timeout here, because it's kind of difficult to see what the hell is going on. So maybe at some point it just doesn't make any sense anymore. Yes. And it doesn't print anything. Did I forgot to? I forgot to recompile it! God fucking damn it! I will never succeed in the game development industry. Holy shit. Okay, I forgot to recompile, and I'm trying to debug a program that I never fucking recompiled. But Zozin, just program in dynamic languages. In dynamic languages, you never have to compile anything, and it just works. But Zozin, it's your fault. Yes, I know. Fuck. Make minus b, bb. Alright, and it just becomes very fucking slow, and then you can increase it, and you can make it super slow. It goes and then slow down, and then it just goes and then you can stop. It goes What if we actually don't limit this entire shit? I think it's gonna be kind of cool. If you know what I mean. So we're never gonna be limited. At some point it's gonna be literally 0. And once it hits 0, we won't be able to go back. Yeah. So once it hits 0, you cannot slow down. You literally cannot slow down, because slowing down is based on multiplying by 2. But if you hit 0, right, because of the rounding and stuff like that, it basically never goes up at all. And that's why I have this limitation, right? You cannot make it smaller than this value, otherwise you won't be able to recover it, and so on and so forth here. See what I mean? So we can go brrr, and then you can slow down. You can make it as slow as you want. Maybe by 2 is too much, right? So here we actually dividing it by 2, right? So this is division by 2 and then multiplication. What if we actually divide it by 1.5? So maybe it will create a better feeling. Yeah, it starts to kind of make a little bit more sense. Yeah, by half is a little bit better. Okay, so that's pretty cool. So x speed gen tick up, slow gen tick down. Is it too much? Slow down the gen tick, yeah. So space toggle pause, and it would be actually kind of cool to also have an indication that you're speeding up or slowing down, but like with pause, But I'm not 100% sure. But maybe that should be alright. Cool. So, and it should work on all of the machines though. So I can slow down, and then I can try to run, if I rebuild everything, of course. I think we should try to rebuild everything. Why do I rebuild it one by one? I can just do minus G5, and it rebuilds all of them simultaneously. And I can slow down, and I can speed this thing up, and then I can slow down again. Yeah, so that's pretty cool. It's a pretty cool framework, not gonna lie. It's like Goalie, but as a library. Imagine if Goalie was a library, like C library. That's what I'm developing. We think that programmers can easily get a job, and if not, he can earn. He? Did you just assume the programmer's gender? Be careful with that, especially on Twitch. So, all right. Now, let's do a committee. I'm sorry. Sorry for what? Our daddy taught us not to be ashamed of what? Wow, what? Cannot come up with a joke. So, let me see. Add slowing down, speeding up. Implement changing speed of gen tick at runtime. Room time. What is a room time? Let's push that. Cool. Okay, so we have a pretty powerful framework now. But what's interesting is that some of the things are implemented on different levels of the frameworks. For example, one of the things that you can do in Wild World is essentially add these things, right? But you cannot do that in Rule 110, because Rule 110 is not a lifelike cellular automaton, right? So, because it doesn't really work on a two-dimensional grid. You can see a two-dimensional grid in here, but it does not evaluate in two-dimensional grid. It evaluates on a one-dimensional one, and we use two-dimensional grid to just show the evolution of the states. So it doesn't use the live framework. It uses only square framework, which is kind of interesting. I think it's kind of interesting. And all of that works together. Like, I really like how we reuse the code, how efficiently we reuse the code, and everything just works. Everything just works. Isn't that beautiful? I think it's goddamn fucking beautiful, mate. So let's actually make it maybe. I want to make it bigger. Make it bigger. I didn't make it bigger. Hello, frontal burst site. Joined, I wonder, I'm seeing here looks interesting. You're seeing our experimentations with cellular automata. Cellular automata. That's what we're doing. So if you never heard of the cellular automatas, it's like small machines on a grid, right? So you can read more about them here, I suppose. Or maybe I can give you a Wikipedia article. So there is a Wikipedia article there as well. Yeah, celery tomatoes, yes. Okay, so let me see if I try to recompile that. Yes. Okay, and I can always speed it up. I can always just speed it up and it will just work. Oh, by the way, what if I speed up the BB? the BB is a Brian's brain, right? So it looks like this, and I can always speed it up, and it's gonna go faster. And then I can always slow it down. And it's gonna go very, very slow. And then we can just speed it up and just go very fast. Yes, that's very cool. Okay, so the next thing we need to do, we need to be able to parse this thing. How are we gonna do that? I'm gonna use STB library. So let me find nothing's STB, and I'm gonna just grab STB image. Let me see. STB image. All right, so STB image resize. I don't really need to resize or write anything. I only want to be able to read images. So let's take a look at the raw version, and I'm just gonna download raw gotcha version of STB image. Let's see. Cool. So how are we gonna do that? So I'm gonna actually create a separate thing. Reader. Let's call it a reader. So it's not going to use any particular frameworks. We're just going to include STB image. And I'm going to try to read the image and recover the computer from that image. So we also have to define something like STB image implementation, if I remember correctly. Bloat. Well, I mean, it's a single library. Speaking of, look. I opened this library in Emacs. Look. And I can quickly jump to the end. And it has 7,762 lines of code, and Emacs can navigate through them really, really quickly. Look at how fast it is. Yeah. It fucking scrolls. So Emacs is not slow, seriously. C mode is shit. C mode is straight up fucking shit. Seriously. Alright, so what we need to do here, we need to define this entire thing, and let's try to do that. So maybe I'm gonna also accept some arguments. argv. So, and if argc less than 0, we're gonna say fprintf std error. This can be error. No input is provided, and we're also gonna say what kind of input is expected there. So yeah, we're gonna put it like this: exit 1. Fprintf std error. Usage reader, some sort of like an image GIF, right? So something like this. This is what we expect here. And now I can do stbi read, or I think load. Yeah, this is how we do that. You just load this thing like that. So this will give me a data. File name is going to be arg. Let's actually define file name like this. It's going to be const char file name argv. argv1, right? Not less than 0, less than 2. Come on, bruh. And it's gonna be x, y, n. I don't remember what is 0, to be fair. Is it like expected? Expected thing. Alright. Basically to encode it to something else. Now I'm gonna try to print all of them. D. It's gonna be D as well. X, I didn't want to do that. X, Y, N. And by the way, if data equal null, not equal null, right? I'm gonna do it like that. Else, fprintf, std error, could not read file S, and I'm pretty sure it sets error no in case of an error, so this is probably something that we can utilize here. str error no, there we go, and then we're gonna exit with 1, and what else do we have here? It's gonna be std lib and maybe string, and maybe error no. There we go. Make minus b, make minus b. Okay, so maybe I just need to go in here and then put a reader in here and only build that reader. There we go. So what do we have here? And thank you very much. And this is why I cannot use WR, because STB is written like comparison. And I'm pretty sure, like, speaking of, I remember that some people submitted pull requests to fix that warning. Has he ever addressed that? Does he even look at that? Signed, right, signed and signed. I remember. So initial signed. No, it doesn't. Comparison. Okay, another one. Of course, it was fixed and never actually merged. All right, so sure, whatever. It's open source. It's open source. What did you want from open source, right? So you get that shit for free anyway, right? So you don't complain, which makes sense. I think it's fair enough. Did I download the GIF? I think I didn't download the GIF. Let's actually quickly download the GIF and take a look at all of that shite. Okay. So we downloaded this. Can you fix it on your local copy? Sure. Now, reader. There we go. So, what is 4? I forgot. Is that the amount of channels? I don't quite remember. What is it? Now, I want to do some sort of like a histogram, if you know what I mean, and compute like how many colors do we have here, right? How many colors do we have? We have a white color, blue color, and the copper. Okay, let's do that. So it's going to be a reader. And so let's do something like this. It's going to be probably uint32t, and that will require to include stdint, right? It will require include stdint, and we're going to have colors capacity. So let's actually set colors capacity to 800 by 600, because that's the expected resolution in here. That's the expected resolutions, and we're gonna have something like size color size. Number of, oh my god, people, you have the open source thingy. You could have just looked it up. I asked just a rhetorical question, like it's somewhere there, whatever. I think it's amount of channels because it also encodes it, whatever. So stbi load channels and file. It's amount of channels, basically 4 bytes, right? So it's going to be 32 bits. So, and for GIFs, it probably encodes it into 32 bits and whatnot. And then you can have a desired channels as well, right? And desired channels basically will decode, like convert it for you. All right, so add color. So, and you can provide uint32. You can provide the color, and first we need to check if the color exists, right? And we need to check if the color exists, and we can do it like this: boolean color exists, and it's gonna be uint32t. Yeah. This is O of n data structure. You don't have to tell me that twice. I know that. You think I care? I don't. For size Zozin, it's slow! Ah! My CS degree is useless, Zozin, it's slow! Ah! Okay, colors. If color equals that, then we're gonna say that it does exist, and then it does not exist. Cool. So another thing, if color does not exist, Zozin, it's square. Ah, Zozin, what are you doing? Colors size plus is gonna be color. Cool. Okay, so now we can adjust that colors. And another thing I want to do here is essential. Oh, by the way, speaking of, I need to do an assertion just in case that colors size is less than the colors capacity, right? If it's equal or greater, that means something went wrong. And yes. Okay, so we're gonna do that. Then I'm gonna iterate through all of this shit here. It's gonna be int I, then less than x multiplied by y, plus I. Okay, and then I'm gonna add color. I have to reinterpret that. I definitely have to reinterpret that. On top of that, by the way, I want to assert that n is equal to 4. And this one is going to be u in 32. So, no, that one, not that one. But rather this one, u in 32t. So here's the data. We expect that. Cool. And it's going to be data I. So we add all of these colors. Colors size is going to be ZU, and it's going to be equal to what? Colors size. There we go. And then if I try to recompile this reader, not renderer, or reader. So don't go. Oh my god. Color size. Cool. And we have exactly 4 colors in here. Would you fucking look at that? Isn't that amazing? So because there's 4 of the possible states, we can now try to print those colors, right? It's gonna be color size, and we're gonna print them like so. I'm gonna do print, let's just do print, and it's gonna be 0x. Then usually have 4. That means 08 x, and then we're gonna do colors I, and let's take a look at how many colors we have there. And there we go. Here are all of the colors. Isn't that amazing? So yeah, essentially you can use this image as an input file, and you can map these colors to specific states. Right, you can say that this is straight up red, and that's really strange red, not gonna lie. Oh, this is a transparent red. Okay. Oh shit, I don't even know what's the format here though. What's the goddamn format? So okay, this is probably alpha, right? Because it's the same for everyone, right? So this is probably alpha. So that means maybe it's actually a BGR or something. So this, if this is a red, this is definitely conductor, right? This is white, so that means it's a head. This is a background, and this thing is very bluish, which makes it the tail. Okay, that's actually pretty cool. The background color seems to be missing. No, the background is here. So I think it's, wait a second. A BGR. I think it's a BGR, but I'm not quite sure. At least it feels like it. We can always experiment with different things. Big engine, maybe it's also big engine. Who fucking knows? It doesn't matter. So we can just basically mess with the bytes until it works. So it's not that hard. It should be 4 states plus background. No, background is the 4th state. Yes. You have empty cell, head, tail, conductor. 4 states. Background is the state. Alrighty. Whew. So how are we gonna even do that? So I'm gonna actually bake this entire stuff into the wire world, and we're gonna initialize the board with specifically that. So how are we gonna do all of this? So we're gonna have an assertion, assert that rows is equal exactly. Actually, we can do a static assert, right? We can do a static assert here. Static assert rows has to be equal exactly that, or maybe should be greater or equal. Okay, so it should be greater or equal. Makes sense. And columns should be greater or equal than 800. So I'm just thinking whether I want to make it a runtime check or not runtime check. Let's make it runtime check, because I will be modifying these values anyway, so let's make it runtime. After that, I need to basically port everything we've done here so far. Right, so here it is. So we have colors. We don't need to do any of this stuff. We probably need to do this thing, and yeah, we need to read everything here. So here's going to be that wire world, no input files provided. Then file input is going to be that. Then we're loading everything. We're asserting that n is going to be equal to 4. Then another thing, we want to assert that x is going to be equal to 800. To be fair, you know what? We can assert this kind of stuff slightly differently. We can assert it like this. Rows should be greater or equal than y, and calls should be greater than or equal than x. Okay, that's actually way better, in my opinion. That's actually way better. So, and if we couldn't read this entire stuff, if it's equal to null, yeah, I'm just thinking, so maybe it could be something like this, file name equal to s, just print all of the information that you read, just in case, and if you couldn't, just complain about that. And now the time has come, Make the image optional. I haven't finished the code, holy shit. Okay, haven't finished. Alright. I'm gonna ignore the chat. Holy shit. Okay, row. Hello, Ralph. Welcome to the stream. Rows. Row. Call 0. I wish I had the music, but the music unfortunately is super laggy, and I don't know how to fix it. Zosin, your code is not finished. Fucking why are you writing unfinished code? Stop writing unfinished code, Zosin. It's dumb. Oh shit. Okay, that was a bad idea. I wish I could have a music, but we cannot have music. So, what are we doing? So this is going to be the boards. The board cells, right? Oh shit, that's actually a very interesting thing. Can I? No, I cannot, unfortunately. There is a pretty cool feature in C99. It's a very cool feature. Essentially, you have a function, right? And you pass some sort of an array, right? Let's put it this way. So you have access and you have two-dimensional array. So maybe you pass in a board, right? And you can do the following thing. You can specify rows and you can specify columns. And then you can say that the rows and columns are going to be the dimensions of this array. And then you can actually access this as a two-dimensional array, and the compiler will automatically use these variables for computing exactly like the specific element of the two-dimensional array. So of course, at runtime, like even at compile time, from the point of view of type system, this still decays into a pointer, right? So it doesn't really add that much of the type safety, but also at runtime it generates the code that appropriately that correctly computes the offsets of rows and columns. So this is actually a super cool feature. Do you guys know about it? It's actually super cool. Because you won't be able to do something like that by doing something like this, right? Because it's just a pointer, so the compiler doesn't know how much you have to offset because it doesn't know the size of the row, right? In C, two-dimensional arrays, if you have like this kind of array, right, two-dimensional, it's actually stored row-wise, right? It's stored row-wise like this. So it's actually linear in the memory. And to find the actual place, right, in actual element, you have to know the sizes of the rows so we can skip rows and then find the actual element. And that sort of code helps the compiler to know the sizes of the rows and sizes of the columns and so on and so forth. Does it make sense? And why am I saying that? Why am I saying that? I'm saying that because I want to do something like this. And I'm pretty sure it's not gonna work. But it would be kind of cool if it worked. Because I don't want to compute it myself. But if it's gonna fucking work. Yeah, it will. Yeah. So because this particular context, it has the type of an array. But this thing returns a pointer. So they're basically incompatible types. They're basically incompatible types. So it's kind of a problem in here. So we'll have to compute the, you know, the sizes and offsets actually ourselves, which is, but I mean, it's reasonable, I guess. It's a reasonable thing to do. So data, so row multiplied by the columns plus columns. So this is how we do. So the size of the single row is the amount of columns, and we basically multiply by the amount of rows, and we find the offset, and then we get the columns, and there you go. But this is not how we want to do that, essentially. We want to switch upon different values there, right? Here are all of the values that we want to actually check. So we're going to put them like this. Cool. So, and now this is the background. So that means that board, cells, row, and column is going to be empty. I think we do have a value for empty. Yeah, there we go. So this is empty. Now, so this, if I'm going to assume that it's like a red thing, right? So it's more of an orange. So that means this one is what? Oh boy, oh boy, oh boy, oh boy. It's a conductor. Yes, it's a conductor. Cells, row, column, conductor. This is white. That means I think it's a head. If I understand correctly, it's a head. Yes, so we're gonna make it a head. And this one a little bit more bluish. That means it's gonna be a tail, right? And anything else is essentially unknown thing. Maybe we're gonna even do it like that. Oh, by the way, I forgot the brakes in here, so let's actually put the brakes. Let's put the brakes. Let's put the brakes. And there we go. And where is he from? Who? Who are you talking about? Who are you talking about? Poland? Poland? Who's Poland? I don't understand. Netherlands. But who are we talking about? Who is he? I don't understand. unexpected color, and it's gonna be something like 8x, and we're gonna put it like this. All right, you. Ah, so you're talking about me in a third person, in front of me. So you're that rude. Okay, I'll keep that in mind. Okay. So what else do we have here? So we have this kind of color. Isn't data X long and not cols long? Depends on what you mean. I don't quite understand. You're doing rows columns instead of rows X columns. Yeah, that's true. So it has to be X. You're right. Thank you. All right. So unexpected color, that, and we're gonna exit with one. All right. So you know what? I also want to start the live in posed state. So live go. Let's also set it like posed. But we pose in the core. So, and to access the core, we have to go deep into the square and then core and then posed. Is it posed? True. All right, so let's try to compile this entire thing. I'm gonna specifically build wire world, and it doesn't compile because it's probably called pose, doesn't it? Yes, it's called pose. Oh my god, it's so annoying. Okay, so we don't have argc, char argv. Does it compile now? It still doesn't compile. Oh, it's also complained about some of my code as well. So, initialization of unsigned int incompatible. Yeah, I know that it's incompatible. I'm totally okay with that. I'm totally okay with that. I know that it's not compatible. Just shut up and let me do my thing. Error no. Okay, so let's introduce string.h. Error no. And is it gonna... Okay, so now I assumed yet again that this is a pointer, which is, it's not, it's actually an actual value. Cool. Wire world. Okay, so now I need to go to the square and set 8 to 6. And let's see if it's correct or not. I'm a little bit nervous, chat. I'm a little bit nervous. Let's actually see. So wire world, yeah, I fucked up with new lines as usual. I forgot to put a new line in here. Right, I forgot to put a new line in here. Oh boy. Make minus b wire world, something like that. And okay, so that's reasonable. Wire world. Okay. So where is the GIF thingy? How is the GIF thingy called? Oh, it's called like this. So if I did everything correctly, there we go. All right. Cool. Are you ready to unpose it? It's super slow, actually. It is extremely slow, if you ask me. But it's doing things, I suppose. I wonder how. Yeah, it's also really difficult to see what's going on. But encoding to try. Yeah, so encoding actually kills this entire thing. So, but it's doing its best. Maybe we shouldn't florf it. When yeah. So the problem here is that like it doesn't form proper lines and whatnot. But at least you can see like 19, and I wonder how much time does it take to actually compute all of this. So can you see that it's 19 here? Yeah, you can clearly see that it's 19. Do we manage to do that? Okay, can you see much? Seems pretty cool. And again, I really like how he or they used the conductors for the comments and whatnot. All right. Let me see if I can improve the quality a little bit. So when I'm rendering the square, or rather in a core, right? When I'm doing in the core, so I'm gonna do the fill rect, the fill rect. What if I don't floor fit? All right. What if I seal it? Because it gets. Oh, what the fuck? Excuse me. Sylph. You guys are asking too many questions. Make minus b wild world. Alright, so is it gonna... Okay, you can see shit now. I wish it was a little bit faster. How can we make it faster though? Is there any way to make it faster? So I'm thinking how to make it better. Yeah, it's extremely slow. We can try to just increase, just to see what's going on. Yeah. I'm just waiting when it's gonna change to 18. I wonder if it will change to 18 at some point. I think it's like encodes a countdown or whatnot. At least it's trying to. We definitely need to implement some sort of like zoom in system. I think it could be actually super convenient. Oh yeah, so we managed to actually load things up. Can you change colors so it's a little bit more clear? We can try to use the original colors that they used, but they are slightly inverted. Right, they're slightly inverted. Okay, so the original colors that they used are these, right? Do we need to invert them? So I'm just gonna copy paste this entire thing, and I'm gonna just put it like that, and it's like this. So the empty should be 0 actually. Yes, empty should be 0. The conductor itself should be something like 0x ff80 00ff, right? The head is actually white, right? So white. And the tail is 00, yeah, 0080 ff. So something like this. We can use the colors from the image itself, and maybe that will make it a little bit better. So is it better? It actually looks like the GIF. It literally looks like the GIF. So this is GIF and this is our rendering, and we can just start doing things. Does it look better? Mm-hmm. But the numbers are clearer now. Cool. So, yeah. That's the actual timer, I suppose. I'm not sure what exactly it is, but and I don't know how much time it will take to actually flip the number. I suppose it will flip the number at some point, but it's kind of difficult to tell. I wish it could we could speed it up. Is this an electronic circuit you simulated? Not really. I'm simulating something called Wire World. Wire World. So Google up what is Wire World. It's a cellular automaton which is suitable for simulating electronics. And what we did, we actually downloaded the, I guess, some sort of like a circuit developed by the creator of this cellular automaton, and we put it in our simulator. First, we implemented the simulator for this particular cellular automaton, and then we loaded the circuit and actually simulated it on our machine for the purpose of actually seeing if it works or not. It's doing something. It's doing something, but I'm not sure what exactly it's doing and when the number is going to flip. So, yeah. And I wonder if we'll be able to speed it up at some point. And how can we speed it up, actually? Is it any way for us to speed it up? All right. So because we for the past 3 days, what we were doing, we were messing with different cellular automata. I don't know how to pronounce it. Cellular automata. So and this is one of them. And it's actually pretty cool. And by the way, speaking of, I'm gonna keep it like on a separate thingy. We loaded this circuit literally from image. So they provided an image with like a GIF image, and we had to, yeah, the only way for us to actually simulate it and put it in our machine is to load it directly from the image. So I wonder how can we speed it up? What's the best way to speed it up? I'm not quite sure. Is there a delay sleep somewhere to slow it down so we can see the animation? Feels like a shouldn't be that slow. Okay, I'm gonna actually slow it down. I don't know if it's. I don't know what you're trying to see here. I don't know. But to be fair, I want to keep it as fast as possible because I want to see when it's going to switch to something, or whether it's ever going to switch to something. Parallelize? Probably. That's not a bad idea, actually. Can you simulate antics for every frame to see how it is? Yeah, that's actually a pretty interesting idea as well. Yeah, I need to write it down. So, where's my readme? Here it is. Speed. Maybe I need to actually put it somewhere in a live. Square is the next gen. Okay. Speed up simulation ideas. Several states per tick. Parallelization. So sounds like a pretty good way to go. Yeah, it could be interesting. We might help shaders help though. What? All right, so I'm gonna make a cup of tea. Does anyone have any questions while I'm making a cup of tea? don't have any questions. It would be cool to actually make the image loader a part of the like Square framework as well, or Live framework as well. I think that would be kind of cool. Is the calculation taking so long or the rendering? I have no idea. I just implemented the simulator and I loaded some circuit from the internet, and there you go. So you think I know what's going on? No, I have no idea what is going on. I just implemented the simulation and that's it. I didn't look into why exactly it's slow because I just run it. Like just literally 10 minutes ago. I just finished implementing this thing 10 minutes ago, and you're asking all this question to me like, do I look like somebody who knows what the fuck is going on? I just implemented it. I wasn't aware you just started. Well, people accuse me of writing unfinished code on stream all the time, so I'm kind of got used to that, don't worry about it. So... alright, so... I really want to make a small break, but without any music, it's kind of awkward to make the breaks, so... because if I try to play some music right now, it's definitely going to be choppy. No idea. This is not as... I'm seriously need to make a break, and this is not helping me. Joking around about that doesn't help me. Yeah, it's shit. Maybe not. It's actually not that bad, maybe. Alright, let's make a small break and yeah. Let's see how it goes. Okay, I'm gonna stop this one because it probably slows down a lot. So, the next thing we could do... Okay, we have two ideas. I have two ideas. Try to speed up the simulation. Or try to look at other cellular automata. Because we have at least two of them. With a gas automation and some ends and shit. I don't know which one. To be fair, we have a lot of time, right? So we only streamed for almost 3 hours, to be fair. We streamed for almost 3 hours, so it's hard to tell if we're gonna have enough time for all of that. So, but speeding up things is kind of fun. So yeah, it's hard to tell. Small break. Let me do it like that. 3 minutes. Right. What is the ants one for? To study ant behavior? I have no idea. I didn't look into that. But you can go to the project and click on the link about ants, because everything I have here, right, is available publicly on GitHub. The only thing you need to do project command, click on this link, read carefully, find the link, click that link, and read about that specific cellular automaton. Right, I have no idea. I didn't read it. Read about it. This was suggested by the viewers, so yeah. I don't know what it is. We'll take a look at it. I never like read about Wire World either, and I just implemented it on the stream, and yeah, that's pretty cool. Anyway, so let's make a small break. You guys have fun. All right, the music seems to be okay. How everyone is doing. So let's continue. You know what I got? I got a pretty cool idea. I want to take the code that loads the wire worlds circuit and move it into the live framework. And I also want to extend the functionality of actually taking the current state of the live thingy and dumping it as an image. So let's implement the thing that you not only will be able to load an image as a circuit, but also dump the current state as a circuit, as an image to load back later. I think that's very cool. I think that will be actually super cool. And that should work like with any of the cellular automata. Yeah, imagine like taking the Brian's brain and save it as an image and then just passing to someone else and just load it up. I think it's actually kind of cool. Hello, Potato passing by. Welcome to the stream. And what's cool is that you can always check out the state of the world without having this program because it's just an image, right? So we keep the state in the image itself, right? Okay, so my tea is ready. I'm gonna quickly pour the cup of water and I'm back. I think it would be kind of cool. I'm really glad the music is actually working. At least I can listen to it now. So I definitely want to maybe save some of this stuff. Okay. So let's create a folder with images. Let's create a folder with images. So here's gonna be that. So, and I also want to put a readme in here, right? Images of different life-like game states. Life-like, yeah. So yeah, like. Why is it called? Wait, I'm an idiot. Yesterday I actually read it like. Am I that dumb? I have a dyslexia. Holy shit. Okay. So, and basically we were talking, yeah, I see, I probably need to visit the doctor at some point. Holy shit. Okay. So so I'm gonna put this thing here. So I'm gonna actually remove this thing. What else do we have? So I don't need a reader. And the reader, and in a make file, we don't need to build the reader anymore. We need to build the reader. Okay, so here's an image. So I removed W error, which makes sense, I think. So here's the wire world. Here's the wire world. So in here, by default is posed. I think it's a good idea to keep them posed by default. But maybe not, I don't know, because it's not particularly intuitive initially. It's not particularly intuitive. Alright, so here is some other separate stuff. So there's that, and in the core, yeah, there we go. Load 8 by 60 into wire world simulator. Is that how you spell it? Yeah, this is how you spell it. Okay, so I'm gonna push that. It would be kind of nice to like have a little bit more structured thing in here with different screenshots and whatnot, but I'm not sure how to implement that, so alright. So I'm gonna mark, not gonna probably mark it, so let me push that right into the repo, so it should be available at here, and it's gonna be Automata. There we go. So here are images of different life-like. Holy shit, I'm so dyslexic. Oh my god, I look at this and I realize how fucking dumb I was yesterday. Holy shit. Makes me feel so fucking bad. Like I really need to visit a doctor, what the fuck? It's just fucking unsettling. Anyway, so yeah, let's first move the code that loads the state of the board into a separate function that is part of the live framework. And once we do that, let's implement the opposite one that dumps the current state as an image. So to do that, we'll need stb write image, right? So we'll need stb write image as well. So nothing's STB. Let's find STB right. I really want to also fix like STB warnings because they're kind of annoying. All right, and they kind of Okay, so wire world. So in a wire world, I suppose we're going to have a function, right? Something like live load board from image, right? Live load board from image, and you provide the board, right? You just provide the pointer to the board, and you provide the pointer to the file path, right? So here's the file path. But on top of that, you also need to provide the callers, right? The callers to properly parse everything. So, and we're gonna do a similar trick as we did in the live framework itself, right? So, live go. So you provide the amount of callers, and then you provide an array of callers. So we're gonna use the same array to parse things. So essentially, we use the same callers to parse, display, and dump the states of the game, which is actually kind of cool. Yes, we're gonna use the same thing. So here we're gonna do cells count, and then we do const caller, cells caller, and we use the cells count in here. You see, this is the trick I was talking about. I'm actually using this trick from C99, which allows you to pass a variable here, and then use this variable in the type definition of an array, and the compiler generates the code that appropriately calculates the offsets and stuff like that. This is actually very convenient. But I mean, for this particular case, it doesn't need to be, like, it doesn't require any offsets, but yeah. I didn't know about that. Yeah, so, but it doesn't check it at compile time. At compile time, this is just a pointer anyway. It's just a pointer anyway. But you can just use that at least to document what kind of size of the array is expected. I mean, cells count, it has to be count, of course. Expected, right. Alright, so and then here we do what? We load things up like that. Right, so we have, let me call this W and H. So it's gonna be W and H. I think it's a little bit better that way. At least I like it better. Right, and then here, we're gonna say that we expect, I think I already have that. I'm gonna just move all of these things in here. Right, this one is gonna be W, this one is gonna be H. We don't need any of that stuff. Right, any of that stuff. Maybe we don't even need this stuff in here. Right, maybe we don't need even that. So, and after that, I'm taking this entire loop, and there we go. So, yeah, so we have callers, we have different callers, and now we need to iterate through them and assign things accordingly. Oh, by the way, this is actually so... why didn't I think about that? Thank you so much. Where did I put it? I put it in live. Also, try 03, right? Try 03. That's also a pretty good idea. Thank you so much. So this could be one of the things that we can try to, you know, speed things up, speed the simulation up. 03 should help a little bit. But then, yeah, we probably will be able to go further than that. Okay, so in here, what we need to do, we need to iterate through all of the callers. So we're gonna have like a cell, cells equal to 0, then cell less than cell count. I think, is it cell count or cells count? Yes, I called it cells count. It's pretty inconsistent. There's nothing you can do about that. plus plus cell, and now cell scholar cell if, that's quite important, if this thing is equal to that, well, that means the board cell in here, the board cell should be equal to cell, like this, and then we break out of that specific loop, right? We break out of that specific loop. And interestingly enough, if we never encountered, so we also need to report an error if we encountered unknown caller. I think we should loudly break, but maybe not. Maybe we should just ignore it. Maybe we should just ignore it. So how can we ignore it? So let's introduce something like boolean found, and it's going to be false, and found true, and you know what, we can even do something like this, while found, while not found, right? So while not found, and if not found, we can say that we encountered a very weird caller that we never saw before. Yes, so it's going to be fprintf. So we can also provide the file path, unknown caller. It's going to be 0x, actually 0x08x, and then we're going to just exit with 1. There we go. I have to provide a file path. And the caller itself, right? So the caller itself is here. Might as well actually maybe extract that to a separate variable, who knows. So it could be something like caller like this. So we can take this entire thing and just replace it like so, and there we go. So we have it like that. So now it uses the same callers, which is kind of nice. So we have that, and then we can do live load board from image. We provide the pointer to the board, then we provide cell count, and then we provide cell callers, cell caller, and here we provide argv1, and there we go. We have a special function that allows us to do all that stuff. Isn't that amazing? I think it's goddamn amazing. Alrighty. So let me try to compile this entire stuff and see if it actually works. It doesn't compile because it's a file path. All right, it's a file path, and here it's a file path again, and now what else? Shit. And oh my god, so these warnings in STB are extremely goddamn annoying. Holy fuck. Maybe I should fix them. Let me try to fix them, because like nothings. Please merge that pull request. Maybe I should actually ping him. STB, maybe nothing's STB. Maybe I should ping him, compare. I'm pretty sure he's never gonna respond, because he basically ignores everything. Which is, I mean, I'm not actually blaming him for that, because he maintains a pretty popular open source project, so it's probably extremely overwhelming. Compiler warning. Okay, so maybe I'm gonna do that manually. I'm gonna. Some data was corrupted somewhere. Okay, so we're taking size of another size, so that means it should be relatively safe to convert it directly to int. And let's do it like this. So is it gonna work? Oh shit, it worked. Variable set but not used. Okay, so that means I can comment it out. We have unused variable. Okay. Wait. It is used. What the fuck? GCC. Fucking GCC. Holy shit. Trash compiler. Straight up. Oh, it's probably a bug in the compiler. Yeah, Clang doesn't complain, but also it has... Yeah, Clang doesn't complain, but Clang has a different bug that makes complain about this shit. It's also a bug, by the way. This is a bug of Clang, of the old version of Clang that I'm using. So... do we have a single non-buggy C compiler in 2021? I don't need to report that bug because it was already fixed in later versions of Clang. So it's just... well, I mean, I just need to update the Clang, but updating Clang on my machine is a pain in the ass, so I just don't do that. God fucking damn it. Anyways, so I'm gonna use Clang. And, okay, so now it complains. Okay, so assert and it's not equal to 4, really? That's very strange. Oh, this is because it doesn't exist, I think. Yeah, and we have to do it like that. We have to actually put it here. Couldn't read file, no such file or directory, exactly. Images and unknown caller. Oh shit. Oh fuck. Oh shit. Oh fuck. Sarimon, welcome. How are you doing? Welcome to the streamers. Oh shit. Oh fuck. Oh fuck. Oh shit. Okay. So empty. But we also need some sort of like an actual mapping. Alright, we need an actual mapping. So I think we need to have like a second cell caller. And this one is gonna be parse caller. And this one essentially uses this stuff where we have 0, 0, 0, 0. Maybe like FF 0, 0, 0, 0. Yeah, I need to... Yeah, I need to take that and just do the mapping from that. So this parse caller empty is going to be that, so 0, 0, 0, 0, 0. So head is going to be FF, which is correct. A tail is going to be that, which is correct. And conductor is going to be that, which is also correct. Okay, so and instead of using cell caller when we're loading things up, we're going to use parse caller. Hopefully that will make the thing work. Yeah, there we go. Look what we've done. That's cool. So basically it's a cellular automaton that emulates the circuits. Right. Yeah. And we loaded the circuit from a GIF file. Yes, we loaded the circuit from a GIF file. Yep, that's pretty cool. I'm not gonna lie. And by the way, I think I'm gonna keep these colors like that. Yeah, so what we implemented, essentially, we implemented the while world, right? So we implemented the while world that looks like this. Right, so here's the description of this particular cellular automaton. Well, that please. It's super simple, right? Seriously, it's just a cell, like a game of life, but with a cell with 4 states, right? And then we found the following image. the following image of a circuit that implements some sort of like a counter, and we parsed this image directly, pixel by pixel, interpreting each pixel as a cell, and we loaded it into our interpreter, and we simulated it, and simulation appears to be working. It appears to be working, so we're just refactoring this kind of stuff. So we're loading the state of this thing directly from an image, and that's pretty cool. Yeah. We're using this to be a library to load images, but it seems to be working. That's cool. It is pretty cool, not gonna lie. Alrighty. So, and what I'm doing now, I'm generalizing the ability of loading images as the states of the game, so we can use it for other games. For example, we have other games implemented, like Brian's Brain, for example. It looks like this, right? It's almost like Game of Life, but prettier. Yes. With transgender colors. So what's cool about this particular Cellular Automaton is that chaos generates pretty interesting patterns. Alrighty. So let me see what we have here. So yeah, I want to actually commit everything. So this one is going to be fix STB warnings. And this one is going to be... did I actually commit too much? Oh yeah, okay. So what I wanted, essentially, I wanted to move this function into the framework so we can reuse that. Right, we can reuse that. Now, so we have, yeah, like this. We don't have to worry about that. The next function I want to implement is the function that actually saves the current state to the file, right? Saves the current state to the file. And the question is, how can we do that? All right. So let's quickly implement that. So I want to be able to take the state of, for example, BB as a Brian's Brain and save it to the file as well, to PNG. Okay, so it's going to be live dump board, maybe save as an opposite to load. Save board to image. It's going to be it's going to take this const board, but unfortunately it also will need a buffer. It will also need a buffer where we're gonna save all of that, right? So yeah, const char file path, and we also need to take the cells count and the colors that we want to use for the states of the cells, right? For the states of the cells, cells count. All right, and okay. Choosing the format is not a problem. Holy shit. You're focusing on wrong problems. So we need like a static thingy here. So let's introduce like a static uint32 data, and the data is going to be rows and columns, right? Rows and columns, and it's going to be like this. So the first thing we're going to do is just to convert everything. Oh shit, I need to make a small break, chat. I really need to make a small break. Maybe smaller, I'm not sure, but I really need to make a small break. Fun. Yo, what's up, Epic Gamers? How's it go? Alright, so let's iterate the rows. Starting from 0. Row less rows, plus row, then it's gonna be call, 0, call, calls, plus call, Epic Tomatoes, yes. And since we have this data, I can just assign that. So this actually makes it kind of not thread safe, right? Because it's essentially a global variable, but it's hidden from anyone else. But it could be messed up if you actually run this function from several threads. But are we gonna run it from several threads? I don't think so. Even if we parallelize the rendering of of calculating the next state, we're probably going to have like a pool of workers that just basically modify the board itself, but they are all going to be synchronized when I need to save the board to the file, so it shouldn't be that big of a problem in my opinion. So it's going to be rows and columns, and what we're doing here, we're just taking the board cells, row and column, and we're mapping it to the colors. It's themselves color like this. There we go, that's pretty cool. So, and what we need to do here, we just need to save it now, right? Nothing particularly special. We just need to save it. It's probably going to be saved in the incorrect format, but maybe that means I'll have to refactor some of my code. Alright, so I have a special function called library stb image write. So speaking of what is difficult to read or write, we're using the library to manipulate manipulate images, so it's not that big of a problem. So what I'm using stb image, which is like a single header library that lets me read and write images. So it is not a problem. So thank you so much, Nothings, for implementing all of that. stb image write, yeah, stb is absolutely great. I use it all the time when I need to manipulate images or just quickly dump some data as an image. It's just perfect for that. Right, stb image write, right, so we can have it like that. stb image, yeah, there we go. So we can write it as png, as bmp, as tga, as jpeg, hr, whatever. So I think I'm gonna use png. I think png should work for this particular case. Save. So we already prepared the data, and let's just save that data. So we're gonna be saving it to file path. Width is going to be the amount of columns, height is going to be rows, the amount of components is going to be 4 for this particular case, and I'm going to provide the data that we just prepared. Stride in bytes is essentially calls, but multiplied by 4, right? So yeah, the amount of components is 4, and this is going to be the thing. And I don't remember what exactly it returns in case of an error. Maybe we can find implementation. Okay, alright. So it returns 1 in case of success, I suppose, right? If we hit this particular place, that means we succeeded, I think. Yeah, so in case of an error here, we free everything and return 0, so that means 1 is a success. If not this thing, we can report an error saying that oopsie doopsie, you did a fucky wacky, ooh, error, could not save to file as because of as, file path, and so we're gonna use str error, error no, there we go, and then we're gonna exit with 1, boom, q. Oh shit, this is not what I wanted. It was cool, but this is not what I wanted. So, alright, so what do we have? And of course, a goddamn classic. Warning. Alright, another goddamn classic. Okay, so here's the call. Anything else? Rows. Error no is undeclared, so probably need to include it. error node.h. Okay, anything else? STB image, implicit declaration of STBI. Ah, well, it's not an implicit declaration. Ah, I see. So we need to do it like this. Yeah, might as well actually put it like that. Delay size. Okay, so, and I need to use Clang because of that. Alright. Might as well actually parallelize that in 5 threads. So to make it a little bit faster. Because Clang compiles slower than GCC for some reason. Redefinition of STB SSE available. We have a redefinition already? Oh, I know why. Because wire world actually also includes this kind of stuff, so we need to remove it from here. Yeah. Cool. Okay. Let's implement something interesting. In live.h, right? So we reset the board when you press R, right? If square core keyboard, you press, let's say, S, right? You press S, it should save the current state of the board to the file of some sort. But the question is how is gonna save, where is gonna save that? So I think it should actually accept the file path as a parameter. So save file path, something like this, right? So basically the implementation itself will tell where exactly to put that. And now I'm gonna grab this entire stuff. Right, grab this entire stuff and I'm gonna put it here like this. To be fair, we could also make a pretty interesting thing. Well, maybe we can do that later. So the board, we need to take the current board context boards, context boards current or board current. I don't remember. Yeah, board current. So file path is going to be save file path. Cells count, we do have the cells count in context cells count, and in the context cells count we have this thing. So that should be it. So every time you try to save it, every time you press S, it actually saves it to the file system. So let's see how it's gonna work. Does it compile? It does not even compile properly. Context, board parameter, so it has to be a pointer, I see. So it failed specifically in the wire world, but maybe... okay, so what do we have here? So in a BB is going to be BB PNG. Then in another one, this one is going to be goal PNG. Depending on different games, we're going to save them differently. So wire world PNG, anything else? And here seeds PNG. There we go. So we're going to be reusing that in several places. Okay, so now we don't have any PNG files in here, right? So I try to find them, they don't exist. I'm gonna try to run BB. Oh shit. Yeah. That's very interesting. So this is because it was too big. Let me try to run it one more time. Yeah, it is very slow. But that's very cool as well. Okay, so I'm gonna go to the square. And I'm gonna reduce this entire stuff to just 100, right? So I'm gonna just reduce it to 100. I'm gonna rebuild everything. I'm gonna rebuild everything. It would be kind of cool to actually set the size of the board according to like the image that we're loading. I think it would be kind of nice, but it probably would take too much time to implement. All right, so I'm gonna save it right now. I'm pressing S, and it failed. Could not read file. Read? I wasn't reading it though. No such file or directory. Okay, so when I press S, let's go to the live.h. Here's S. Oh, I want it save. Yes, that makes sense. Okay, I need to rebuild everything. G5. There we go. Okay, come on. Undefined reference save board to image. Okay, I'm sorry. Save board to image. So I can stop it now and I can save it. Then I go here and okay, that's very interesting. So let me open it in the Chromium. So here's the image, but the colors are completely fucked up. Probably because PNG, like STB, expects it in a completely different order or whatnot. What's interesting is that I'm pretty sure we can then use this image in wire world, right? In wire world, like this BBPNG, and it has a known, yeah, it has a known colors. Yeah, the colors are not standardized, but yeah, but it actually saved it. It actually saved it. If you can see that. So here's the state that we saved as an image. So, but now we need to think how to properly do the colors and whatnot. Because I originally choose the wrong order of the channels, and now I'm gonna get fucked by it. So it would be kind of cool to have like a colors that are sort of encoding channel independent, but maybe not for now. All right. So that was an interesting idea. So maybe I'm gonna work on it a little bit later, at some point. All right. So let me save all of that, and also let me git ignore any PNG files in here. Right. Implement saving state functionality for live framework. I'm gonna push that right into the repo. So let's try to see if we can speed up the wire world, right? So wire world, let me do the following thing, where I'm gonna just use it like that. It's gonna be 8. Well, this one has to be 600, right? This has to be 600, and I'm gonna rebuild everything just in case. I really hate this warning, but I cannot do anything. Unused but set variable. It is used! Oh my god. It's so dumb. Holy shit. And it's used down there. It's literally used down there. Holy fuck. It's so dumb. GCC is so goddamn dumb. Alright, so wire world and images. Okay. Okay, so here's this thing, and let me see if we can speed it up just by enabling O3. So if O3 will be enough for that. It will probably slow down compilation of everything in here, but we'll see. Okay, it actually compiled faster than I expected. It's kind of sus. No, it doesn't compile faster. Okay, so it's actually still compiling. Alright, let's wait. It's still compiling. It probably tries to optimize like the STB image, STB headers as well. Holy shit, that's that took quite some time. Holy fuck, it's like full optimization including the STB libraries. Right, STB libraries required like a separate optimization and stuff like that. Holy fuck. Okay, so let's see if the wire world became faster. So maybe it did. It kind of became faster, but not really. Yeah, not really. Next 3 pixels, please. Twitch compression goes rip. Okay, I see. All right. So it's probably gonna take a lot of time. By the way, did I compile this entire stuff? Yeah. Okay. So let's actually try with Clank. Let's try with Clank. Maybe Clank is gonna do a better job at optimizing everything. The next thing we can try to do is to simulate several steps per frame, which shouldn't be that difficult. It's just, yeah. But that should be done on a whole new level, if you think about it. It should be done on a whole new level. So essentially, we usually in event loop we return true or false, indicating that you should compute the next state or not. So we need to refactor it into return an integer that tells you how many iterations you have to do. Yeah, that's what it should be. It will return you how many iterations you need to make to accommodate for the speed up and whatnot. I think it's a pretty reasonable solution. Anyway, so I just compiled with Clank. Clank seemed to work. So let's put it like this, and I'm gonna speed up everything. And it didn't really provide that much of a speed up in my opinion, so that was kind of meh. But yeah. Okay, so but I'm gonna actually commit that as well. All right. Enable O3, and I'm gonna just push that right into the repo. All right, so let me see. So we make a decision whether to compute the next generation at the level of the core framework. Right, at the level of the core framework, we have next gen timeout and next gen cooldown. Right. So, and the places where we use all of that, yeah, there we go. So core is next gen, so we basically check whether we need to compute the next generation or not. So, and then that's pretty cool. Yes. So essentially, once this thing becomes less than 0, we just reset the cooldown. Furthermore, I think we need to put it behind the pose, right? If it's not posed, only then we do all of these checks. But it's kind of hard to tell. So essentially, we need to be able to have a counter, right? We need to be able to have a counter. So in the context, we're gonna have next gen count, and essentially next gen. So this is gonna be kind of complicated. But if it works out, doesn't fucking matter. If it works out, doesn't fucking matter. So the counter is next gen. Okay, so we are extracting next gen count, right? And essentially what we're returning here, we are returning the result. We're returning the result, which is the context next gen count, like this, and then I reset next gen count to 0. Next gen count to 0. So once you get it, it gets reset. All right, then here is the interesting thing. If it's less or equal than 0, we reset it to timeout. And we can do it something like this. Okay. So we are about to subtract the delta time from the cooldown. If the cooldown is less than delta time in seconds, we have to actually kind of take the delta time in second and split by the cooldown, right? By the cooldown. Oh, it actually depends. All of that depends. So basically we have two modes of operation. The first mode of operation is when the timeout is greater or equal to the delta time in seconds, and in that case it's just super easy to do things like that, right? Otherwise, if it's smaller, we don't even use the cooldown anymore. If these things, we have to do next gen count ++1. So if it's less than delta timeout, what we do essentially, we do delta this, we get the timeout, we split it by the timeouts, and I guess we can actually seal it, maybe forfeit it. It depends on whether we want to do that. Well, we want to do that exactly. And then, right, we add that to the gen count. So basically, if the timeout is so small, it will force the loops to compute several times. And I guess that's pretty much it. So that may work. So let me see how well it will work. So we're gonna test on a rule 110 is next gen. So we don't have a next gen anymore, and we have to do that in square, god damn it. Okay, so is next gen count, and it's also next gen count. So we're gonna only rebuild rule 110 and see how it goes. Alright, so what is it complaining about? Semicolon, cool. Alright. Essentially what we wanna do, we wanna take this and save it, save the count. We wanna save the count. It's gonna be const like this, and for size t less than count ++I, and we just do it like that. Oh my god. Okay, so it has to be like this. There we go, and That should give us appropriate thing. That should give us appropriate thing is next gen count. Cool. So let me see if it will go a little bit faster after that. So I can actually well, that's very interesting, but it doesn't really go that much faster unless we actually limit the minimum even further, like 10 times slower. So it's gonna maximum G5 is gonna be rule 110, something like that, and I can make it even faster, and we can probably move it even faster. What are you doing? It must be going fast, but it doesn't, even if I... does it really affect anything? Doesn't feel like it's affecting anything, but maybe it does. Well, it slows down because of the rendering, that's for sure. It slows down because of the rendering. Maybe we can simply... Yeah, I think the rendering is actually fucked up. Maybe we need to keep track of the like dirty rectangles that needs to be redrawn, if you know what I mean. Huh. That could be a way to speed up. Yeah, so this is another interesting thing to speed up stuff. So I'm gonna go to the live. So we already tried all three several states per stick. We're currently trying it, and here don't redraw cells that didn't change. Right, so this could be a thing to speed up stuff as well, but there's not much we can do about that because the core actually redraws, like cleans up the like everything for us, so there's nothing much we can do about it. Or can we? That's a good question. Can we do something about that? But yeah. Anyway, so I'm gonna try to now rebuild Game of Life and see how that thing will go. So we have a complaining about these things. Do we have a complaining about anything else? Yes, it's working. Alright, so count, I'm gonna do it like this. So even if we have, we need to do it like this, so it's gonna be context rule, like that. And it's gonna be size t count, next gen count. You didn't step up for a bit, you actually step away for a really long time because it's been working for quite some time already. Alright. To the point that I couldn't be bothered to stop what I'm doing right now to show you. Because we're already like sick of it working. For 2 hours, exactly, I just cannot be bothered to stop what I'm doing to show you, like literally, because like it's been too much time already. Maybe if you're lucky, maybe I'm gonna show it again. Well, I definitely will show it again because what we're trying to do, we're trying to speed it up. Alright, so we're gonna take the count, and we're just trying to simulate it for several ticks as well. Alright, so is it gonna be working? Hopefully it's gonna be working. Yeah, okay, so it seems to be alright. It's very slow. Yeah, I'm pretty sure it's because of the rendering. Rendering kills like literally everything. And in this particular case, I think switching to shaders would be actually very beneficial. because in that case, like, remember the initial idea that I had of using like a texture for the shader? I think it would be cool. Yeah, but it's too late anyway. Okay, several state per tick didn't work. Don't retrieve the cells that didn't change. I think it's not gonna work for core. Let's actually try to see if wire world works. So I'm gonna rebuild everything, including wire world. And will it speed it up? I'm not sure. I don't think it will speed it up, but maybe it will. Because if the bottleneck is rendering, that means it should work. Yes, it should work. It's just like a full optimization. We're doing full optimization right now. Okay, so then it's gonna be a wire world, and I have to provide the image, and there we go. So this is how it looks like if you wanted to see. So the Twitch encoding probably makes it unbearable to watch, but this is basically how it looks like. And it's working. It's simulating this thing. I think it sped it up. I think it did. It definitely feels a little bit faster, but still rendering of all of that is just not particularly fast. It's super cool. I guess it's kind of cool. Okay, one of the things we can do, we can actually take the board, turn it into image, turn it into surface, right? Turn it into surface. Yeah, and just render it as a surface. That's one of the things we can do. But that will require a completely different approach. Kill switch video, yeah, I know, but there's nothing much you can do about it. So that's also an interesting idea. Well, don't redraw cells that don't change. It's kind of a meh, but yeah. Jiang, what's up? I'm dead. Who's writing then? Hello, welcome. How was your prologue adventures, by the way? How was your prologue adventures? Yeah. So we've been doing that. We're trying to speed this thing up. And this is a cellular automaton, by the way. This is an actual cellular automaton, and it tries to like emulate a counter and whatnot. And it's the wire world. It's the actual wire world. It's the one that was suggested on the stream. So wire world. Yeah. It literally kills the bitrate. Yeah, I guess. There's nothing much you can do about it. This one, basically Game of Life, actually Seeds. It's not really Game of Life, it's literally Seeds by Brian Silverman, but with 4 states of the cell, right? You have 4 states of the cell, and you have conductors, you have electrons, and yeah, we implemented that, and it seems to be working. We also implemented a parser that can load this state of the cellular automaton from an image, right? We found this image on the internet, and we, using STB, we just loaded it into our emulator, and it seems to be working. So yeah, it's kind of cool. It was actually super easy to parse because each pixel represents the cell, and cells with different color represent different kind of cells. So it's cool. And we're trying to speed it up. Speeding it up, it's actually pretty huge pain in the ass. I have no idea how to speed it up. Well, I have a couple of ideas. We already tried like O3. Yeah. So it essentially gives you transistors. Which actually probably explains why there is like a interesting theory. I suppose I heard at least that among the physicists there's a theory that the whole world is essentially like a simple cellular automaton with simple rules, right? So, and everything we see around ourselves is basically emergent behavior of those rules. And some people are trying to find those rules. I don't know how much true it is, but have you ever done project with AI? Depends on the definition of AI. What is AI? And let me guess your answer. You're gonna like literally translate me abbreviation and tell me artificial intelligence, right? No? Or I don't know. Anyway, so let me see. Because like it's kind of interesting. I've been asked this question so many times. Like a lot of people ask me, have you ever done AI? And the first question I ask, what is AI? And the first answer to that they always say, it's artificial intelligence. Like, thank you. Holy shit, that makes a lot of sense. It's like it's also the same with OOP. Like every time I ask what is OOP, people say, oh, object-oriented programming. Yeah, I answer your question. Now you answer. Thank you. Cool. I'm really sorry that they behave like that. It's just like when you've been asked this question like hundreds of times, it's just you cannot take this question seriously. I'm sorry. That's good. I'm really sorry so that I behave like that. Holy shit. Okay. So, where is the drill didn't change? Parallelization, I don't think parallelization is going to be that particularly useful. Maybe it will be. Okay, go. So essentially, how do we render the board? Right? How do we render it? We are just render it cell by cell, right? We just render it cell by cell. So in SDL we have an interesting thing called surface, right? So we have a surface, and surface is basically an image in the memory, and we can, I think, simply turn the surface into a texture and then render that texture, like slap that texture onto the screen. So this is one of the things we can do. And that could be a pretty cool optimization because that will not require scheduling a lot of rectangles to draw. Right, it will not require scheduling a lot of rectangles to draw, it will require scheduling only one single surface to draw, and hopefully that will be fast. Maybe we will be able to even modify like SDL texture directly on the fly, but I'm not sure if it's possible. So you can lock the texture, and when you lock the texture, what can you do with it? You can modify the pixels, okay. So as an optimization, the pixels made available for editing do not necessarily contain the old texture data. This is write-only operations, and if you need to keep a copy, this is actually perfect. This is actually goddamn fucking perfect, because we can now allocate the texture, right? We can now allocate the texture of a specific size, and every time you need to like render a specific rectangle there, you can, oh holy shit, this is so goddamn cool. I think we'll be able to optimize this shit to the roof. Right, so we're gonna just keep a single texture. Did I ever... So, okay, so the question was, did I ever did any neural networks, right? If that's the question, okay, that's a good question, by the way. Because at least neural networks have a very specific definition, or like better definition than artificial intelligence, right? So I didn't do anything sophisticated with neural networks, but I implemented a very simple neural network in Haskell. Does it count? Neural network. I think it's somewhere there. I need to find it. Neural network. So it was a long time ago, like 2 years ago, but yeah. On the topic of other artificial intelligence things, I also did genetic programming. So is that artificial intelligence? Because, well, it's not a neural network. I don't know. So that's why I ask, what is artificial intelligence? What do you mean by artificial intelligence? So I also did genetic programming. Is that artificial intelligence? I don't know. To be fair, in 1970, any algorithm of traversing a graph were considered artificial intelligence. So just finding like a shortest path in a graph could be also considered artificial intelligence. But by today's standards, like nobody actually thinks of it as artificial intelligence, right? So what is artificial intelligence? You see, it's a not really good term if you want to ask about this kind of stuff, right? It's better to always ask about specific techniques, specific algorithms, specific data structures, like specific things, because artificial intelligence, it doesn't mean anything. It's a marketing bullshit, right? It's a marketing bullshit that is used to, get money out of the investors, because investors, they just hear the word artificial intelligence and they're like, oh, artificial intelligence, oh. So, but we are not investors. We don't have money. Marketing bullshit doesn't work for us. We engineers, we talk in specific terms, right? Did you do big tech? God damn it. You got my point, Torunor. I really appreciate it. You got my point. All right, let's see. So we need to now do a little bit of optimization. Luckily, I abstracted everything away, so we won't have to modify too many things. Hopefully, we'll see. So essentially, how do we render everything? We have a special function called square fill cell, right? Square fill cell. Hello C252. Haven't seen you in a while, by the way. How are you doing? Hello. So, haven't you watched me for a while because I said something dumb? Because that's usually the case. Quite often people just don't watch my stream for a while because they hear me saying something dumb. And they leave. I don't know. Okay, I'm really glad to hear that. Okay, bye bye, Jiang. See you around. Good luck with your prologue stuff. Machine learning feels kind of the same to me, even though it feels less abstract than AI. Yeah, it's also the same, like marketing stuff. I've just been busy with the school. Interesting. School. I haven't been to schools for quite some time already, and I kind of miss it, to be fair. It wasn't a stupid question, it was just like not really informed one. I wouldn't say it's stupid. Alright. You're welcome, I suppose. So here we have a special function that basically accepts rows and columns and color. And what it does, it just calls core fill rect. That's what it does. It just calls core fill rect. And luckily, I think I don't use this function anywhere except here. So yes, that's perfect. So this is a perfect abstraction. So once I remove it, nobody's gonna complain about it. That's actually perfect. So the only problem we see here is the grid, but that shouldn't affect anything either. All right, so what we have here, we need to allocate SDL texture. So this is going to be board texture, and it's going to be pointed to the texture. Cool. How can I create the texture? So let me see. So again, how we render everything right now? Right now, we're literally scheduling rendering of a rectangle for each individual cell. That's how we do that, which is extremely slow. Because it overwhelms SDL. And by the way, SDL also allocates a lot of memory on each scheduling of the rectangle, so it's a mess. So what I want to do now, I want to allocate a single texture, render the state of the board into the texture, and then just render the whole texture as a single, like a draw call, I suppose. I don't know how many draw calls SDL does. And in theory, it should optimize everything, hopefully. So let's create a texture. So you can even create a texture with a specific format. All right. Vegetables. Are you eating vegetables right now? I wouldn't mind vegetables, actually. So. Interesting thing about vegetables. I absolutely love broccoli. And you know why? You know why? Because when I was a child, we didn't have them in the place where I lived. When I was a child, broccoli were never a thing. So I was never forced to eat them when I was a child. I only tried them when I was around 20. So, and I really like them. I think it's kind of a thing. Like, I think a lot of people in US or Europe absolutely hate them because they were forced to eat them when they were children. And the same thing goes with, for example, Pascal in Russia, for example, or in Eastern European countries, right? Because people are forced to learn Pascal in schools there. And since people are forced to do that, they absolutely hate that language. So, yeah. Forcing children to do things is the fastest way. Yeah, exactly. And there's so many evidence for that. There's so many evidence. Yeah. And people keep hating those things until the rest of their life, actually. It all starts from the childhood. Cellular Automata, cooking with studying. Yeah. By the way, I know about hello. How are you doing? Really glad to see you. Pascal is cool, yes. And you know why I like Pascal? I was never forced to actually program it in school. It was kind of interesting. I discovered the Pascal for myself a year before they started to teach us in school. So I discovered it myself, I liked it, I learned it, and then next year we started to do it in school. And because I already knew it and because I already like it, I was never actually forced to do that. You were first. And do you hate it? Do you hate Pascal? You probably do. And that actually makes sense to me. So I think people should never be forced to program in Pascal. Even though semantically, it is not that different from C, actually. But you program in C just fine, so. I was forced to use C and I don't hate C. Interesting. Yeah, I have bad feelings. I see. That makes sense. It also all depends on the teacher that you had. Right, so if the teacher was an asshole, right, so you might also especially hate Pascal. I hate Pascal and broccoli. Yeah, and there's nothing wrong with that, so I don't think there's anything wrong with that. Alright. So we do square begin, and we also need to create everything in here. Alright, so it's gonna be a context and board texture. I really want to eat something. I'm really hungry. Chat, feed me. I'm hungry. Alright, context core renderer. We provide the renderer, and the question is, what kind of formats can we have? Want some chocolate? I wouldn't mind. Would be kind of cool. I haven't had chocolate for quite some time. So the thing about dark chocolate is that you can eat it for a while and then you get sick of it and then you don't eat it for quite some time. And I think I'm almost at the point that I want to start eating dark chocolate yet again. So yeah, I think I'm gonna buy it soon. That's how all sweets for me. But I don't really eat sweets, that's the thing about it. I eat dark chocolate, like 97% or higher, that contains almost no sugar. As a matter of fact, I don't eat anything sweet at all. Because I was trying to lose weight, I already lost weight, and now it became a habit. So I cannot eat sweet anything anymore. Yes. I liked Pascal, Turbo Pascal 7 specifically. Pirated copy at the time. Run uncompiled code lightning fast, even on a flop. Exactly! So here's the problem. So the computers in 2021 are perceptually slower, way slower than they were before. Right. They are not like actually objectively slower, they're actually supercomputer, but perceptually they become slower and slower and because of the software. Software actually drags the performance down. So software makes the computer slower, then they become faster. So it's just fucking insane how Turbo Pascal was blazingly fast from a floppy disk. And 2021 we cannot render like DOM fast enough for which website. Parity Turbo Pascal 7. Classic, we had it at school. Yeah, so at the time, like, I mean, Russian schools pirate a lot of software. But don't tell anyone. Don't tell anyone. Yeah. Primarily because they cannot afford all this stuff. That Shadow X, thank you so much for 6 months of tier 1 subscription. Thank you, thank you, thank you. And welcome to our epic Pascal clap. So what I want to say? Yeah. So a lot of like a school program is actually very old, and it's too much effort to change, and to switch to a different software, to open source software, will require changing all of the program materials, and schools just cannot afford that to do. So the easiest and the cheapest way for them is just to start pirating software. It's actually very common in Russian schools, which is kind of sad, but yeah. My school, I think, managed to switch to Linux and Free Pascal. I think they switched. But this is because that school had a lot of attention, so they won't be able to successfully pirate software. Yeah. And in school we don't have like computer science or programming classes. We call it informatics classes, probably just like in Germany or something. And my informatics teacher absolutely fucking hated Free Pascal compared to Turbo Pascal. Yeah. So like the level of quality actually is, she says that the IDE is just like worse than the original Turbo Pascal IDE. You had Pascal ABC. Oh, I think I heard something about it. But I think she switched to Free Pascal. We used to have Ubuntu on a USB stick and boot from it on the school computers. Oh, interesting. Currently for school, I'm basically forced to use Visual Studio, Windows, and everything is Azure and cloud. It's kind of frustrating at times, yeah. We drew algorithm diagrams on a blackboard in informatics classes. I don't remember doing that in school. I don't remember doing that in university though. In my uni, all computers have Windows and Ubuntu installed. Nice. I also grew up in a poor area, so computers at school was a no-go, but some of the software can be costly, so I can understand. Yeah. Alrighty, so we need to create the texture. So that's the problem, we need to create the texture. Okay. So format. So what's going to be the format? Width and height. Width is the amount of columns, as far as I can tell. It's going to be calls, and height is going to be rows. So the format, pixel format enumeration. So which one should we use? Can I have something like RGBA? I want to have RGBA 55. No. Yeah, I want to have RGBA 32. This one. It's my favorite. Chat, what is your favorite pixel format? Mine is RGBA 32. Which one do you use? There's a lot of them. But yeah. This one is actually easy. RGBA 69. That's a good one. Nice format, I would say. Very nice format. Changes rarely not lockable. Changes frequently lockable. Can be used as a render target. Render target. I'm web dev, so hex codes. God damn it. Pixel format, hex codes. That's cursed, thank you so much. Okay, so I think we need to do texture access streaming, because I'm a streamer, so yeah. So, and we managed to create a texture. Would you look at that? We managed to create a texture. Nice. Oh, nice, 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 nice. So, SDL destroy texture. So I think that's what we'll have to do here. We'll have to destroy the texture. Okay, so we're gonna do it SDL destroy context board texture. Cool. Now. So when we fill the cell, we're not gonna do this shit. What's that Google logo? Wait, what? Did it change? Is that one? Ah, it's Valentine's Day. Valentine's Day. That's what it says for me in Russian. Valentine's Day 2021. I don't know if it's the same for you. It could be regional actually. So in here is an interesting thing. When you start rendering, right? When you start rendering Valentine's Day. So we're doing the grid, but we also need to lock the screen, lock the texture. So let's do it like that. SDL texture lock. Yep. SDL texture lock, maybe lock texture. Yeah, lock texture. So the texture lock access, which creates this is filled in with the pitch of the locked pixels. The pitch is the length of the. Okay, that makes sense, I suppose. Broken streamer. I'm sorry. So this one. Critical error, broken streamer, broken goddamn streamer. Mongolian third singing stream. Yeah, probably. I'm not sure if I do that in a very authentic way. I'm not sure how proper to do that at all, to be fair. So also we need to give the pointer to where it's gonna store all of that, right? So this is a board texture, and I guess, yeah, we know for sure that the format is going to be 32 bits. I might as well actually keep it like this, 32. So it's going to be pixels and board pixels, board pitch, which is going to be just an integer. I'm not worried till he starts repeating exterminate. Exterminate. Okay, so here's the pixels, and we'll need to take the context. Exterminate piece. Got me. Okay, board. Where's the board pixels? Where are the board pixels? Okay, so here's that. Context, board, pitch. I'm actually super proud of at how I managed to organize my abstractions, which makes it super easy to introduce this optimization. It's fucking cool. Cool. So then we unlock the texture, and how do we unlock the texture? We just provide the texture to unlock it. Cool. Yep. Context board texture. So this is where we end the rendering, and in here, when you wanna do that, essentially, what we do is just that, and then we do the context. Actually, yeah, context board pixels. We take the board pixels, and we need to access the row. Row is going to be, we need to access the specific pixel. Row multiplied by context board pitch plus the column, and this is where we're gonna assign this entire thing. So yeah, we're just assigning a specific pixel instead of using fill rect, because we don't feel rect. Chat, tell me, do you feel wrecked? My best joke. Oh, I'm sorry. Okay, so after we did that, we need to slap that texture onto the screen. So how do you slap it? How do you slap the texture? Slap that texture. SDL copy texture. Right. We need to copy the texture. Render. I think this is render copy. Yes. Slap that texture onto the screen. Right. So it's gonna be SCC. So we have to provide the renderer context. Do I have to lock it? Do you have to lock it to slap it? I don't think I need to lock it to slap it. Do you have lock? No, it doesn't even lock it. Okay, cool. Context board, actually just a renderer. It should be available in the core renderer. Yeah, there we go. So then I take the texture, board texture, and then I need to organize the rect. Const rect. So this one is going to be 0, 0, but also width and height. So width is columns and height is rows. Yeah, there we go. So, and that means I should be able to replace this entire stuff with just rect. Cool. So just render copy rect, and that should be okay. Cool. I think I've done it. I think I literally have done it. So I replaced scheduling shit ton of rectangles with just drawing everything into a texture, and I did that under the abstraction of the framework without the breaking of the abstraction of the framework. This is actually amazing. I really like it. So, and it should work automatically for all of the examples, including rule 110, which is also goddamn amazing. Alright, so let me see. I'm gonna try to rebuild everything and see how it will build. Okay, so context. Passing argument 3, lock a texture from incompatible pointer. So it expects void star, but the argument of the type is u. Okay, oh come on, dude. Seriously? Okay, I can just do it like that then. Probably bad idea. Okay, so maybe I need to store the board pixels in void and then reinterpret it later. I think that's what I have to do. Then I have to reinterpret it later because that's what it wants here, so it's not that big of a deal to reinterpret it later. I can always do something like pixels, where I can just take the context board pixels, right, like this, and just do pixels like that. Yeah, sounds pretty good to me. Oh shit, it compiled already. It fucking compiled. I wonder if it's gonna be faster now. Holy fuck. It's compiling. It's fucking compiling. Alrighty. So I want to start with something small. Oh, by the way, textures also have linear interpolation by default. So if we reduce the resolution, to something small, like rows, Weird question perhaps. Do you enjoy yourself while coding your own project? Well, do you see my hands? You know the answer. Okay, let's continue. So we need to wait until the end. I'm just joking, of course. Yes, I don't enjoy myself, of course. Yes, how would I? All right. So, yeah, essentially, let me rebuild rule 110 one more time. Okay, so rule 110 and okay, and it's sec faulted. Nice. I see. I see. So the source should be rows and columns. Ah, I see what's going on. Yes. Render copy. So this is SRC. So SRC is okay. SRC is okay. Then we're gonna have DST. DST rectangle is gonna be from 0 to screen width and screen height. But why did it sec fault? I'm not quite sure. Like oh no, I'm using pitch. Pitch is correct. So I don't know why, but yeah. So the first time, that means you don't watch me. That's basically what it means. Sorry. All right, so that kind of worked, but not really. So this is pitch and this is column. Oh, I think I know what's going on. We need to multiply this entire stuff by... Well, no, not really. Pitch is in bytes. Oh, shit. I see. I see now. I see. So this has to be like 8. Then this has to be multiplied by 4. And this has to be multiplied by... Well, no. A row... Yeah. And this has to be multiplied by 4. Right. Then it has to be reinterpreted as 32 and then saved like that. And that... Yeah, okay, that actually explained why it was so bad. Right. I take the pointer to that, then pointer to that, then dereference that point. Holy shit, that's a whole new level of shit. And that explains it. Okay, there we go. So that's pretty pogue. And we render everything into the texture. And that's pretty fast. Look how fast it is. That's pretty cool. So all of that is rendered into a texture, and the colors are kind of fucked up, but maybe that's okay. So, and what's funny is that it didn't really make it super like smooth. It didn't try to apply bilinear interpolation, which is perfect in my opinion. So, okay, let's try to look at more sophisticated examples. Minus B, and we're gonna rebuild everything. So this might be the best optimization we can do for our simulation. Basically optimize the rendering, right? Render into the texture rather than by rectangles. So yeah, it takes some time to rebuild everything. But once we're done, it should be super fast. Because essentially, we are using hardware acceleration for all of that. Okay, so let's take a look at the goal, game of life. And game of life goes... Okay, so what about this thing? So this is Brian's brain, and it's... Holy shit, look at how fast it is. It could be actually super fast. That is so nice. Alright, so that's super cool. Now, the moment of truth. Why world? The colors are fucked up, by the way. I am aware of that. But what I'm trying to do, I'm just trying to get the basic rendering done. Okay, so that means we need to change the square rows. It's going to be 8. It's going to be 600 by 800. Okay, so that's pretty cool. I need to rebuild the wire world. Yes, kawaii desu. So, and we need a pretty fast, you know, simulation for that machine. If we ever want to see that number being flipped. I'm not sure if we're ever gonna see that number being flipped, but if we ever see that, that's super cool. Okay, and I can speed it up. And it's extremely fucking fast. Holy shit, it's fast. And it's so smooth. You probably cannot see that, but it's extremely goddamn smooth. This is the best optimization you come up with. Okay, I can probably increase the size of this entire stuff so we can see better. Look at that. It can actually scale infinitely faster. Infinitely scale infinitely, that's what I want to say. And it slows down for some reason. What the fuck, why is it slow down? Alright, and you know what? It should be also possible to implement like built-in zoom-in feature that will zoom into the particular texture, because we're not scheduling a shit ton of rectangles and whatnot. That's actually so cool. That's such a cool optimization that they came up with. And yeah, we can remove this entire thing. It's not needed anymore. So I can even probably get rid of the core field, but yeah. So rendering directly to the texture is absolutely amazing. Let me go to core and allow even faster simulation. So 1, 2, 3, 1, 2, 3. So it's already 6, maybe even like that. So let's actually make it even faster. And does it make it super fast? I'm not sure. Now port it to Vulkan to maximum performance. To be fair, theoretically, it should be super easy. You know why? Because I'm using SDL. And I'm not using anything OpenGL specific. So that means if I just enable... oh, I forgot to recompile. Yeah, thank you. If I just enable Vulkan backend for SDL, and as far as I know, SDL has a Vulkan backend, this thing will just use Vulkan. Right? So, yeah. I abstracted away from specific APIs. So, yeah, I can easily port it to Vulkan. And it's probably going to be super fast as well, because I'm using like texture abstraction, and I would assume that texture abstraction actually does everything fast. Like it uses the best representation for that specific driver. Yeah, I forgot to recompile. Thank you so much. So alrighty. So let's actually speed everything up. It doesn't really go that fast. What if I do the following thing, where I will set the initial timeout to the minimum one? Will it do the trick? Because I want to make it super fast. I think there is... I also hit the next limit. Yeah, it's relatively fast, but not that much. So if I can make it super small, magnitude small. Alright, if this doesn't work, I'm gonna move further and implement zoom-in feature so we can zoom on particular parts of the of this thing. It doesn't really become that much faster. By the way, is the encoding okay? Is the encoding okay with this particular color scheme? Or is it unbearable? It's way better than before. Probably because of the colors. It's different colors. Still not okay, so yeah, different colors, like just encoded differently. I really want to see when the thing flips. But when does it flip? Does it ever flip at all? To which video compression? It's not a counter made out of gold, it's a counter made out of wire world. Wire world is a cellular automaton from the same family as Game of Life. But, so Game of Life has two states of the cell. Wire world has 4 states of the cell. So it has a dead cell, conductor, head of the electron, and the tail of the electron. So yeah, and it's suited for simulating, you know, this kind of circuits. Okay, there is a fat thing going down here. Do you guys see that? There's a fat thing going down. I wonder if it will trigger the flipping to the next number. So this fat thing. So let's see if it's gonna trigger anything. I don't know. I never seen it counting up or down. I've never seen it do that. So I'm kind of curious as well if it's gonna do that at some point. It's probably a counter. I don't know. Like. Okay, so now there's another like long thingy going up. When it will trigger? I tried my best to optimize it to make it faster to actually see how it will count up. So I'm afraid that maybe I made a mistake somewhere. Is it starting to do something? I feel like it's starting to do something. There's something changing between... Oh shit, something changing here. So... Oh shit, it might be actually flipping soon. It might be actually flipping soon. So let's wait. Let's wait if it's flipping soon. Because something in the states of these digits is changing. Can't change frame time. I already made it as fast as I could. Do you even watch the stream? Come on. I optimized the timing. I optimized the rendering, so the rendering is super fast. So I'm afraid, what if I actually did something incorrectly? What if it's compiled with 09? Is it even a valid flag, 09? Or maybe it waits for some sort of input? So we should have actually read about this thing. Maybe it requires some sort of input from somewhere. I wonder if we can mess with it by firing an electron somewhere. So I'm gonna mess with it. Okay, so I messed with it and it's probably gonna destroy it completely. I can mess with it, I can click on things here and just, yeah, just destroy it. Yeah, yes. Oh shit, look at that. I messed with it, yeah, it's completely broken now. That's cool. And it's cool that it actually, yeah, it shows it. Shit. Nice. You can skip generating. This is exactly what I did! Do you even watch the stream? I enabled optimizations 03. I skip the generations. I skip the rendering for several generations. And I also sped up the rendering now. I used efficient texture. This is what I've been doing for the past hour. Does anyone watch my streams? Okay, cool. So what I wanted to do Yeah, it's pretty cool. It works. So let's try to do this BB. I kind of want to see that on a bigger scale. On a way bigger. I want to see it on a way bigger scale. So I'm gonna do -GB. I literally just yeah, sure. Okay, so let me try to do that. Oh yeah, I want you to do the zoom. Yeah, I want you to implement the zoom feature. I want you to implement the zoom. Alright, so... Oh shit! Look at that simulation smoothness! Holy shit! I can even speed it up. Yeah, that is so smooth. And this is because it uses hardware acceleration for all of that stuff. Yeah, boy. Quality of the stream went down, but yeah. That's so cool. Oh. Nice. I came up with a pretty cool optimization. I'm super proud of myself. Alright, yeah, I want you to zoom now. So what did I implement here? Optimize rendering for square framework. I'm gonna push that right at the ribbon. So you can always check it out on your local machine, by the way. So because the source is open. So. Yeah, let's think about the zoom. So for the zoom we can introduce, I suppose, the position of the camera and the scale and whatnot. Yeah, so we can do something like scale. Originally scale, I think, should be equal to 1, right? Context. Could the zoom make it faster? Probably not. But since we are rendering into the texture, zoom is actually cheap, right? So because we're rendering everything into a texture and we just then slap in the texture with a single draw call. So that means to implement the zoom, we can just transform the texture. And that's it. It's actually relatively cheap, so it's not going to affect much. Hopefully, we'll see. So the scale is initially going to be 0. So camera scale. Let's actually call the camera scale. This was render small. Nah, it doesn't matter. So it's not gonna make it faster that way because it's a single. I think because it's a single texture. It's not gonna make it faster, but I'm not 100% sure. Float camera X, float camera Y, and this thing is gonna be X and 0. Yeah. So when I'm ending the rendering, so I take the whole SRC dest, and now I just need to transform the destination rectangle. This one is very interesting because so this is the width and height, and interestingly enough, I think we can simply take the multiply the context camera scale and something like this, context camera scale. So we might as well do something like float W. So this is the actual width, this is the actual height, right, that we can use. So, and we can just make it like this. But the position the position is going to be slightly different. The position is going to be what? Oh boy. It has to be at 0, 0. So I probably need to draw that. My paint. I'm already streaming for 5 hours, goddammit. And I also need to then stitch together the split VOD because I fucked up. Right. Right, so here's the screen. And so after the scale, I just need to make sure that the center of the scaled thing is at the center of the thing. Twiggy.io, thank you so much for 11 months of tier 1 subscription. Thank you. So essentially, I need to synchronize their centers, right? I need to synchronize their centers and whatnot. All right, and it's already 0, 0. 0, 0 starts at here, so oh my god. So essentially, I need to take the half of the width, right? So here's the half of the width multiplied by half, right? And then subtract half of the width of that one, right? And then plus the camera context camera X. Yeah, that's it. Holy fuck. Okay, const float X is gonna be something like this, right? Y is gonna be height. It's gonna be H. This is X and this is Y. So, and in here I can just use X and Y, and of course I'll need to floor full of this shit. Int floor. Then I'm gonna do it like that. Maybe self. Not 10% sure, but we can try. All right. Okay, that's just a second. So let's rebuild specifically maybe Wild World. I'm gonna start with the Wild World because that's the most interesting thing to zoom in. So the next thing we'll have to do, we'll have to implement some stuff for zooming in. So I'm think how to do. So the best way would be to do that with a wheel. But right now we don't really support the wheel, so let me try to do something else. So where do we handle things? Time to quit. So here's where we enable the grid. I think I need to remove the grid. Grid is kind of useless at this point, but it could be useful. Yeah, it could be useful a little bit later. But anyway, grid should be drawn on top. On top. And where do we don't even render grid anywhere. I think I fucked it up. Core keyboard. So how are we gonna increase the scale? That's a good question. Camera. Scale plus. I don't know, like, yeah. Okay, and minus is going to be minus, but we have to be super careful with minus. Oh, okay, so scale could be a similar situation as with speeding up, right? Increasing the scale is just basically multiplying by 2, right? Multiplying by 2, maybe by half, by 1.5. And you can make it as big as you want. Zooming out is actually dividing by this value, and you want to make sure that this value is not smaller than a particular value like this. Otherwise, it's not going to make any sense. All right, so is it gonna work? Okay, wire world image. Fucked up. Nice. So I fucked up big time. Scale, camera scale. So if it's 1, should be all right. Half of this thing. Okay, so we take half of the thing, and if it's equal to that. All right, I don't see any problems, but it doesn't work. I don't see any problems, but it doesn't work. So if this is 1, this should negate itself and end up with the camera plus, and if it's 0, there's nothing gonna be there. Oh boy, this is literally painful. I think I need to actually print all of these values, and printing them is a huge pain in the ass. So it's gonna be x, y, w, h, and let's see what's gonna happen. Show me your values, please. Y world. Oh shit. Oh fuck. I need to make a small break. I need to finish the stream though, but I cannot finish it right now. Okay. Y, x, and y are this. This is incorrect, by the way. So width and height, half of a width and height is going to be the 1 value. Then we subtract half of this same value. Camera x and y are not correct at all. Why is this 500 like, this is not correct. Where did it get that from? I don't understand. So, but what's interesting is that width and... unless we didn't properly zero it out. Do I have to zero it out here? Didn't I properly zero it out? Maybe I didn't. I thought it's actually 0 initialized. I thought it's 0 initialized. Please don't tell me that it's not 0 initialized. That means I make a huge mistake. No, it is 0 initialized. Okay, that's kind of interesting. I'm already falling asleep and I don't see a mistake. I'm becoming blind to very dumb and simple mistakes. Somebody help me. Oh boy, okay. Scale is pretty straightforward thing. This, yeah, should. Initial, oh my god. Nobody suggests anything new. Oh, okay. I thought I actually set it to 1. I put 0 there, and I thought I put it 1. That's why I never think about it. So the reason why I never checked this one, because I was 100% sure that I put 1 there. Otherwise, what's the point? Okay. Okay, come on, recompile it. Takes too much time. I should probably disable O3 because O3 is not helping. Okay, that was too much actually. So let's change it to something like maybe 1. Maybe 1, and I think this one is actually something like equal because it didn't allow me to properly do that. Okay, so we can now actually finally zoom in. and it zooms out too fast. But overall, yeah. Huh. But you can zoom in actually quite a lot on each individual pixel, and then it just goes to oblivion. I wonder why. Because you have to take a maximum between them. So, and yeah, so we can do a pretty thing like that. And then you can zoom out. You can zoom out quite a lot. And it doesn't affect the performance that much. We can probably even get rid of the relative size, because everything, like all of the rendering is done within... Look at that, it even has numbers like 41, 43. This is something that I couldn't even see before. Yeah. We can see even smaller individual things in there. You can now pause and then mess with one of the things. Oh, I cannot. Yeah, it doesn't properly map. It doesn't properly map the clicks. So it would be kind of cool to actually go somewhere there. Would be kind of cool to go somewhere there. Let me think. So if context, so I'm gonna actually map some of the things there. Core, keyboard is gonna be, let's actually say I. It's gonna be context, camera Y, and we're gonna subtract what? We can subtract a particular value, like 100. Maybe not 100 pixels, but maybe like 50. And I think it should depend very much on the scale. So the bigger the scale, the bigger should be the step, right? So that means maybe we can multiply this thing by the scale. Multiply this thing by the scale. I wish it compiled faster. But yeah, all three optimizations, they take too much time. Okay, so, and if I'm gonna do I, it actually goes in the wrong direction. Okay, so it should be plus in that particular case. And maybe it should be actually like around 10. So once we've done that, I'm gonna map the rest of the keys, and we can go ahead and navigate through the machine and just look how it works and stuff. Yep. Seems to be working. And I can go somewhere here and just look at what's going on there. That's pretty cool. All right. So if it's I, this one is going to be key. Is going to be a minus. So all right, so this one is going to be a J, and it should modify X, but it should actually add, I think. J is going to be L. This one is going to be subtracting this entire stuff. So let's see. So it will enable us with actually exploring all of that, and it will be kind of cool to map the clicks and stuff according to the zoom. There's a lot of things that needs to be done here for making it even more epic than it is right now, but unfortunately, like, we just don't have too much time to do that. Okay. So we can explore some different things. For example, the creators of this thing, they wrote like different URLs and stuff like that. We also have this thing. So sometimes it's kind of like zooms out in a really weird way, but yeah. So there's these digits. It's super cool. This is, yeah, it's actually pretty cool. Wait a second, bus error. What the fuck is a bus error? I really like how they have these small nodes within the machine itself. Right, so bus error, bus error. I think it probably lights up when you have some sort of a bus error. Look at the copyright. Look at the copyright. This is so cool. Let's just like think around the copyright. This is so awesome. Holy shit. This is like advent of code worthy shit. I'm not even joking. So essentially you can have a problem where the input is this kind of machine, and you need to simulate it and it will write something for you. This is so goddamn cool. Literally, this is advent code worthy thing. And what's interesting is that for advent of code, right? So the actual answer could be visible only after like several like millions iterations or something. So you have to make it like super optimized, or something. Wait a fucking second. Is this an input? Wait a goddamn fucking second. Is this an input? I think we found an input. So it has 0, 1, 2, 3. Maybe this is why it didn't do anything? Holy shit. Okay. Wait, what, to be fair, but how do you input? There is nothing to input here. Yeah. Okay, let me actually try to do something like this. So it's gonna be if context core keyboard. Right, we're gonna reset everything to context camera. Context camera 0, Y 0, scale 1. Okay, let me see if it's gonna work. That is so cool. So now I can reset it back to original thing. So that's pretty convenient. So we really need to explore it and just see. Maybe there are some interesting things in there. So this is a bus errors. Bitrate. Is bitrate fucky wacky again? How can I increment it? So this is 1, 2, 3. Maybe we could. This was probably generated by software. You underestimate some people. I'm telling you, this is not as complex as some shit people do manually in Minecraft. Manually. No, I don't think it was generated. It could be as well done by hands. Or maybe, like, for example, repeating patterns could be copy-pasted, sure. But, yeah. So this is not as complex as some Minecraft shit, seriously. Manually. I mean, even with Schematica, you still do that manually. You still have to click each individual, block. Well, there is also like helpers that help you click faster, but I mean, still. This is just a counter. There are fully working GPUs in Minecraft. True. I think something like this counter in Minecraft would be less complex. You're right. Yeah, that's actually a good point, both. This kind of counter in Minecraft is way simpler than this. Wait a second, I think I see something interesting. What the hell is that down there? Do you see that? What the fuck is this shit? It's some sort of a clock. You see? Why is this there? I cannot even modify it, unfortunately, because we don't map everything properly in there. There's a lot of interesting, like, little things here and there that don't really make much sense, but they're there. So yeah. Anyway. Oh shit! I actually had a debug output. That's why it probably slows down a lot. That explains why it was slowing down from time to time, because it was outputting. Just for decoration, but I mean, it's such a small minor decoration that it doesn't really make much sense. Alright. Actually, this particular simulator that we've built becomes more and more powerful. I think it might as well be able to simulate something even more complex, like gases and whatnot. Isn't there a blogger who does a breakdown blogger? You say that they're doing that over several posts or something? I think it's like one post worth or something, I don't know. No, yeah, powder toy. Oh yeah, powder toy could be also very interesting. Alright, so let me do a committee. Introduce simple camera to square framework. Yeah. It looks like a fun application of computer shaders. And what's funny is that I don't really use shaders. So this is done using only SDL, not even OpenGL, not Direct3D, only SDL. Guess how I did that only in SDL? Guess how I did that only using SDL? And basically I can compile it to work with OpenGL, DirectX, Metal, Vulkan, and it will work. So it only uses like a pure SDL. I guess in all pixels, you're pretty close. I'm rendering into a texture. So the thing about texture in SDL, SDL texture. A structure that contains an efficient driver-specific representations of pixel data. Right. So basically I create SDL texture, and then each frame I render the state of the board into the SDL texture, and then I perform a single draw call of rendering that texture onto the screen. Since it's a driver-specific representation of the texture, with OpenGL driver it will use OpenGL textures, with Vulkan driver it will use Vulkan textures, with Metal, and so on and so forth. So yeah, and it will work efficiently on any platforms. So yeah. It's cool. That's what I'm doing. Can we retrace it? Probably. No. Anyway, so it was kind of cool. I wish we could continue, because we still have some stuff in here, but I'm gonna declare Wire World done. We looked into Wire World. It would be kind of cool to look at the rest of them, and also work a little bit on our engine, making it more powerful. But we're already doing that for 3 streams, goddammit. And we still have a virtual machine to implement, so I mean... Do I continue doing this shit? Is this like a month of Cellular Automata? Tomato only stream. Because I want to like try other things as well. I mean, come on. It's kind of interesting. And it's kind of cool to work on this engine and make it more and more like featureful and more powerful, just to be able to power more Cellular Automata. Oh, by the way, if you take a look at other, like BB, for example, right? So this one is pretty scary, but yeah, let's actually rebuild all of the cellular automata. BB, yeah. So the camera should also now work in other cellular automata. Like for example, Brian's brain as well. Full-time tomato streamer. Yeah. I really like it so far. 5-hour streams, by the way. 5-hour stream. I wonder if O3 actually makes any difference. All right, so let's run BB, and I can now zoom in into individual things. Right, you can think of this as like a regular game of life, right? But then you can zoom out. You can zoom out a lot, and there's the whole universe in here. And there's a lot of them. But then you can zoom in, and there's a lot of different things. Pretty cool. All right, so you can find the source code of the thing that we're working on here, so you can check it out on your machine. Yeah, and I think it is time for me to go, boys and girls. I think it's time for me to go. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all tomorrow. Tomorrow, I'm not sure if we're gonna continue doing this thing or not. We'll see, because I kind of want to continue doing it, but I'm not sure if it's gonna become too saturated. Check out our VODs channel, where I'm gonna upload the recordings of the streams. We're gonna have a separate playlist for Cellular Automata streams, so you'll be able to watch them from the beginning. And check out our Discord server for offline discussion with the community. So yeah, today was a cool stream. Thanks everyone. Love you all.